a sky, 'cause you're a sky full of stars. I'm gonna give you my heart, 'cause you're a sky, 'cause you're a sky full of stars. 'Cause you light up the park. I don't care, go on and tear me apart. I don't care if you do. Cause in the sky, 'cause in the sky full of stars, I think I saw you. You're a sky full of stars. I wanna die in your arms. Oh, oh. 'Cause you get lighter the more it gets dark. I'm gonna give you my heart. Oh, I don't care.
各位贵宾 ，Computex 2016 CPX Conference 将于2分钟后正式开始。我们请在场的贵宾能够尽速就座，谢谢各位的合作。Ladies and gentlemen, good morning. The Computex 2016 CPX Conference will begin in about 2 minutes. Please be seated. Thank you. 同时，今天因应讲者要求，今天第一场 ARM 的演讲，请各位在场的嘉宾不要录影或者是录音，我们感谢您的合作。我再讲一次，看会不会回送。Ladies and gentlemen, good morning once again. Welcome to this morning's conference. Before the program begins, may I remind you that video photography and audio recording are not allowed during the first keynote speech today. We thank you for your consideration. Once again, this morning's program will begin momentarily. Please be seated. Ladies and gentlemen, good morning. Welcome to Computex 2016 CPX Conference. This year marks the beginning of Computex rebranding campaign, building partnerships in internet computer ecosystems. Echoing the show's new positioning, this year's conference will explore future technology, disruptive innovation, IoT ecosystem partnerships, and application. And ladies and gentlemen, this morning's keynote session features a stellar lineup of speakers from ARM, Siemens, and Qualcomm. So to kickstart this morning's program, let us first of all invite Mr. Walter Ye, Executive Vice President of Tetra, to deliver his welcoming remarks. Ladies and gentlemen, let's welcome Walter on stage.
Our honorable speakers, distinguished guests, ladies and gentlemen, good morning. 大家早安。On behalf of organizer of Computex, I would like to welcome all of you to join today's CPX seminar. And of course, I would like to express my respect and appreciation to all our speakers, and like the CEO of ARM, Simon Cigars, and also from TSMC, and from Siemens, from, we have so many, I have to take a look. And yeah, we have also Qualcomm, from Qualcomm and Cisco. We appreciate very much for your contribution and sharing with all our participants here. Computex, this year we celebrate our 36th anniversary. So in transition to a new position as a building partnership of internet computing ecosystem. So this year, we are glad that we have 4 new things. One is IoT application and startup innovation and startup and business application, and also gaming as our major things. And we are glad for startup this year. We have 217 companies join our startup Innovex. It is a new try, and we hope we can accommodate more startup from this year. I think startup is important according to Gartner research. 50% of our IoT applications come from startups. So we are glad that we have 217 startups here this year, and 71 from abroad. And among them, 25 companies already got the international awards for startup. And business solution is important. Our this year's Computex is in transformation into business application and IoT application. So you can see more and more companies in this field from Taiwan or from international. So we appreciate very much you come here for this seminar. Computex seminar is important, as very important part of this show. I think this show, I will not talk too much, and we will have more time from the speakers. Speakers, they are all very distinguished speakers, and they will share with you more insight about the industry. Thank you very much for joining us today. Thank you.
Thank you, Walter. Please remain on stage. We're about to take a couple of group photos. We would like to ask Walter to please stay on the stage for group photo shooting. I would also like to invite all the keynote speakers and the co-presenters to please go on stage for a few group photos. Ladies and gentlemen, please welcome today's first keynote speaker, Simon Seegars, CEO of ARM. Zach Shelby, VP of Marketing, IoT Business Unit, ARM. Dr. Cliff Ho, Vice President of R&D, TSMC. And today's second keynote speaker, Erdo Elver, President and CEO of Siemens Taiwan. Dear guests of honor, thank you very much for joining us this morning. Thank you. Dear guests of honor, you may now return to your seat. Once again, ladies and gentlemen, we would like to express our most grateful appreciation to these keynote speakers and co-presenters for their attendance in this year's Computex conference. Today's first keynote speaker will be Simon Seegars. He's the Chief Executive Officer President and CEO of Siemens Taiwan. Mr. Elver started his career with Siemens in 1987. He's well known for his comprehensive strategic and senior management background, as well as over a decade of managerial experience in Asia. Mr. Elver is committed to pursuing the sustainable development of Siemens Taiwan, its customers and partners, and the Taiwan market. So ladies and gentlemen, without further ado, please help me welcome Erdo Elver on stage.
technical。挂上去，过来。technical 人来。这样，就那个。
Test before? Works? Okay, this way. All right, that looks better. Can you keep this? Can you keep this one? Okay. Good. New start. So, ladies and gentlemen, dear guests, good morning, 早安. So this looks better. Now we move from semiconductor companies, very distinguished companies, ARM, TSMC, to Siemens, a totally, let's say, different area. I'm happy to be here. Thank you very much for the organizer for giving us the chance to share with you about Siemens and digitalization, especially focus on future of manufacturing. As someone representing Siemens, a German technology company, a leader in many areas, especially in Industry 4.0, I will go through with you quickly about our view regarding Industry 4.0 and share with you examples. And in my presentation, I will focus on first, digitalization changes everything. This will be the first key statement I will address. I think my colleagues from ARM and TSMC also gave great examples about this. Second one will be, we at Siemens with innovation and innovative technologies are creating and delivering the value in the digital world. The third topic will be, well, we have challenges in manufacturing, especially in many areas of manufacturing. But Industry 4.0 are giving answers to the challenges we are having. And last but not least, at the end, I will share with you our way, Siemens way, for Industry 4.0. You see already an example on this picture where we have already applied our Industry 4.0 technologies, namely in the car industry. I will come back to this and give you some more insights on this later on. Now back to the first topic I mentioned, namely digitalization is changing everything. Yes, it works. Digitalization changes everything. So regarding this, I like to share with you a short clip, video clip. And please watch carefully. This clip was prepared for global usage, but you will also see something from Taiwan. Please watch carefully the next clip. Can I get this? Yes.
Our world is becoming ever more connected. Billions of intelligent devices and machines generate massive data, bridging real and virtual worlds. Complex data now play a crucial role in the way we move, live, and work, the way we plan and create products and services. Turning the vast amounts of data collected every day into value is a key success factor for companies, economies, and entire societies. We have the domain know-how to transform the big data generated by our systems and products into rich information that enables smart choices. Our data-driven services monitor power plants to guarantee reliable energy supply. Our software and IT solutions teach wind powers how to produce more, and our building management systems teach buildings how to consume less energy. We enable our customers to intelligently automate processes across the entire life cycle of their products. And by simulating real-world objects by means of digital twins, we help them optimize their manufacturing processes. Our intelligent traffic management systems help moving people and goods faster, safer, and with less CO2 emissions. And we develop sophisticated medical imaging systems that help doctors make better decisions faster. We seize the data opportunity to create real value.
There was something very close to us. Those who are living in Taipei might have recognized. Yes, there was a picture from 101, and 101 is running, by the way, with Siemens building management technology, and is the tallest green building in the world, again, running with our technology. Now, to my first session, digitalization changes everything. We have seen great examples from my friends from ARM and TSMC, and you have seen also examples in their slides. In fact, in future, in cities, we will have a lot of sensors which are helping us to let's say steer the flow in traffic. The sensors will create a lot of data which will be taken by intelligent traffic systems and help to optimize the traffic flow, or cars will drive themselves. So, and in energy, you have also seen short in the clip, wind turbines, for example, are generating a lot of data through the sensors which are put on the blades, which can be used to optimize the let's say operation of a wind turbine. Or, well, future of healthcare, we will have sensors tattooed under our skin, which will create important health data which can be transmitted to our doctors, which can, of course, draw conclusions about the treatment we need to take. And last but not least, now in manufacturing, machines will communicate with each other using digitalization technology and optimize themselves, and which is also the major topic of my presentation. Now, as mentioned, with our innovative technologies, we, Siemens, are driving the value in the digital world. In fact, we are the only company. Before going into this detail, allow me to just share with you how we define our portfolio. We are looking into the so-called mega trends like digitalization, demographic change, aging, climate change, urbanization, and based on those mega trends, we are defining our portfolio on mostly focusing on automation, electrification, enhanced with digitalization. And the key focus areas, I have just shown you a couple of examples, are future of cities, sustainable infrastructures for cities like building technologies, transportation systems, smart grids, energy management. And future of energy, how we can create sustainable energy for today's but also future generations, using the latest technologies in renewables, respectively, in fossil power plants. Future of healthcare, again, how we can provide affordable healthcare for the society. And last but not least, again, how we can make our customers in the manufacturing area more competitive by utilizing our technologies. So again, that is the short how we define our portfolio based on so-called mega trends, focusing on automation, electrification, and digitalization. Always are keeping in mind with the sustainability as our guiding principle and innovation as our DNA. Again, we are the only company having, let's say, the physical world, all the equipments which we are engineering and deploying in different areas, but also having the virtual world, the data created from our devices and the software which we are utilizing to run the operations in a more efficient way. Today we have about 280,000 connected devices with each other, which are creating around 16 terabyte operation data per month. It's a huge amount, and again, we are providing solutions, software solutions, which can utilize this data and help to run the operations in a more efficient way. I'd like to share with you two examples, and then I will come back to the core topic of today, namely the future of manufacturing. But two examples are from the cities. The one is the congestion charging system which we have deployed in London. And those who might have been in London might know the congestion is a huge topic in London. And we have deployed a system in London with around 1,300 cameras on 300 different locations, which are capturing the data of the cars, millions of the cars, analyzing this data, again, using software techniques, digitalization techniques, and also determining whether, for example, a specific car has paid the congestion charging fee or not, and taking action. So this is a great example where we're utilizing, again, lots of data with the hardware behind, which are deployed in different areas. Wind farms, key topic for future energy, for sustainable future of energy. And here again, wind turbine is equipped with a lot of sensors which creates data regarding the wind speed, regarding the positioning, regarding the performance of the wind turbine, and those data is transmitted to the remote diagnostic center, which is based in Europe. Again, taking around from all of the world, around 8,000 wind turbines are connected in one diagnostic center, and with this, maintenance and service team can take decisions. For example, do we need to maintain, or do we need to replace parts of a wind turbine, or do we need to take certain actions if there are certain cracks in the blades or something like this. So this is another great example where we are using again digitalization techniques and running again the wind farms in a more efficient way. Siemens has a long history, and Siemens is also known with our innovation power. Company has been founded around 170 years ago, and this is Mr. Siemens who have established the company. And all those innovations, if you look at them, we say this might have been called by Mr. von Siemens inventiveness. And today, we call it ingenuity for life. This is our new brand claim, ingenuity for life. And ingenuity means genius products and solutions, innovative products and solutions. And for life is referring to, in fact, the value we are creating for our customers, for the society, but also for our employees. So again, is a new brand we are introducing, Ingenuity for Life, which is matching perfectly with the Siemens brand. Now, to the Industry 4.0 and the challenges. I think all of us might know, and this is not only let's say, related to the manufacturing industry. In many industries, we need to increase the efficiency, especially in the manufacturing industry. And we have to have energy and resource efficient. We have to do things much faster because customers are always, impatient. They want to have the products rather today than tomorrow. So that means we have to shorten time to market, but also enhance flexibility. Different versions of our products need to be manufactured in one production line and others. And those challenges are answered by Industry 4.0. And Industry 4.0, in fact, you can imagine there have been three, let's say, generations or three phases, whatever we call them. The first one based on water and steam, so the mechanical equipments were running with water and steam. Second one is the usage of electricity and the mass production, which we call also here the second industrial revolution. And the third one, which we are now having, is using the automation. And the next one will be the fourth industrial revolution, which is the Industry 4.0, which is using all the digitalization techniques, but also Industry 4.0. And here, again, friends from ARM have introduced different technologies, and those are all technologies we will be using also here in manufacturing. Big data, communication, different devices, autonomous robots, very important for manufacturing, simulation techniques, and many more. Those are key technologies we need to have, again, to run the manufacturing in a more efficient way. Industry 4.0 is, in fact, an initiative defined by the German government around 2011, when I'm correct. And it defines, in fact, a framework, a platform regarding the horizontal integration of the value-add networks and vertical integration of network production elements. So this is something which we have to see later on in some concrete examples. And very important, seamless integration of different, let's say, stages in the value add, from design, production, manufacturing, service, and you name it. Those are important stages which needs to be connected in a seamlessly to run the things in a more efficient way. So this is, in fact, the definition of Industry 4.0. Once again, Internet of Things is changing our life, and we are seeing IoT nearly everywhere in our life, and you see here a couple of examples. Like I mentioned, manufacturing, energy, infrastructure, in healthcare, and you name it. And today, and those things we are doing not only for fun. We want to have things more efficiently. We want to increase productivity, and we want a shorter time to market, and you name it. So those are, of course, important things we need to consider and keep in mind. And today, once again, our topic is manufacturing industry, future of manufacturing, and how we can run things in a more efficient way. And this I will address in the following in more detail. 3 key elements for future of manufacturing. I just mentioned in my slide as I introduced Industry 4.0 as an initiative of German government. The one key element is the networking of and integration of the production networks, horizontal and vertical integration of production networks and value-add systems. So that are the first important element. The second one is here we are merging virtual and the real worlds with each other. Designing things in the virtual world, testing, and at the same time I can look how things will look like if I start to manufacturing and producing things. So therefore, this is another, the second key element of Industry 4.0. The next one is the so-called cyber physical systems. And here we are talking about production units, but also products which will communicate with each other and run the manufacturing in a different, let's say, in a more efficient way. Those are, in fact, the 3 key elements of Industry 4.0. Regarding cyber physical systems, once again, this is Imagine you want to produce a product. Let's assume we want to produce this one. So you have first the model, digital model of it. And later on, if you start to manufacture this one, this will get parts on it, will be assembled, and at the end you have the physical product. And this is in fact what we call the digital model. Is always up to date and remains with the products. In the beginning, it is just a software model, and later on, it is somehow attached to the product, which can also communicate with the devices which are assembling or manufacturing. Allow me to share a simple example with you and see here. This is again from the car manufacturing, and you see also in the slides different elements in manufacturing are identifying themselves. I am the robot, I am the conveyor, I am the robot one, and you name it. And later on, if we start manufacturing, there are different states, like car bodies identified. Now we need the doors, and we need to optimize and reduce the takt time by 10%, you name it, and so on. And that is the interaction between device which we manufacture, respectively between the devices which are manufacturing and optimizing the manufacturing process in an efficient way. Let's look a short video to make it more concrete. This is okay. Can I get my video? Yes.
The challenges facing industrial production are greater than ever before. Product life cycles are getting shorter, costs and competitive pressures are increasing, and the whole process is becoming more complex. Car manufacturers are therefore working together with Siemens to think ahead, for example, by combining virtual and real production worlds. The vision for manufacturing is called Industry 4.0. In the future, machines will learn to communicate independently, to optimize production stages and to fill in for each other where necessary. The benefits include greater flexibility, increased efficiency, and shorter downtimes and setup times. In short, improved global competitiveness. Making things right. Answers for the future of manufacturing. Siemens.
Yes. Now I'm coming to my last section. We have seen now the framework and little example. Now how we see and our way for Industry 4.0, respectively, future of manufacturing. I mentioned already it is important to have a seamless connection of those different stages in manufacturing. If you want to have an excellent product, you need to have an excellent design. In order to have an excellent design, you need to have systems, software, simulation tools who can allow you to make an excellent design. And this starts again with the product design. Then you need to design the manufacturing, the production line, the production planning, production engineering. And then after setting up your manufacturing, you run the manufacturing in an efficient way. All this needs to be, let's say, connected, and you need the full consistency between those different stages. And that is what we are offering as Siemens. And you might know, I mentioned already, we have a very long history. We started, in fact, 130 years ago to provide our customers in the manufacturing industry with first devices like motors and drives. And we have, in fact, introduced around end of 50s, I was even not born at the time, the first automation, production automation system, which we call SIMATIC. SIMATIC is today, as you might know, is standard, like Windows or iOS in the computer world. So then we have introduced in 1960 TIA, which is the totally integrated automation, which allows the interoperability between all the automation components. Then 2009, the TIA portal, which helps you to define the automation in different sectors, in different industries. And starting with 2007, we have acquired software companies and developed software which help, again, as I just mentioned, for product design, production design, and you name it. And in fact, today, we are the only company having the solutions and combining the virtual worlds with the real world, and invested around 4+ billion euros in this area. And in fact, we are already delivering solutions, and we are ready for Industry 4.0. Our solution is what we call Digital Enterprise Software Suite. This looks a little complex, but I will try to introduce, let's say, in a simple way that we understand. Once again, if you want to manufacture something, you need to design first. So for the product design and production design, we are providing the PLM software portfolio, which help us, again, to design on computers with relevant tools, the products, respectively the production, which is a top-down driven process, which also help us to link, again, the virtual worlds with the real worlds. Then we need to design engineering of the manufacturing or the factory, which we need to build to manufacture the product which we just designed. This we are providing, for this we are providing the so-called integrated automation portfolio based on our TIA and TIA portal, which is having components, all the relevant integrated engineering and runtime for controllers, distributed I/Os and drives and motors, what you need to put together to provide the manufacturing for the system. And important is that those two are connected. I mean the PLM software and the integrated automation portfolio needs to be connected to have the consistency and the efficiency. And the second one is, of course, a bottom-up driven approach. Then after having both, you need now to run the manufacturing in an efficient way. For this, we are providing the MOM software portfolio, which helps the planning and scheduling and running the manufacturing, which we just designed with our integrated automation portfolio. In fact, those three elements are the core of our so-called Digital Enterprise Software Suite, which again help us to design and run the things in a more efficient way. And again, this is in fact our answer to Industry 4.0, respectively to the challenges in the manufacturing industry. Allow me to share with you a couple of examples, then I'm done. This is the famous Mars rover, the Curiosity. I believe the design, building, and landing of the Mars rover on the Mars is the most difficult task on Earth. Because Mars is not around the corner. You cannot build a prototype, go there, test, and come back and change and go back and test it. So you need to build it, well, on the Earth without having the ability to go to Mars and test and come back. And this has been done with our PLM software. So the Mars rover was digitally designed, virtually assembled, and function tested, and then built and sent to the Mars. And I guess you know the result. We got beautiful pictures from Mars as the Mars rover was landed on Mars. So this is a great example where we can use the virtual, combining the virtual world with the real world and using our PLM software. The next one, you remember my cover page from the car industry. Maserati is one of our esteemed customers, which they have used our software, PLM software, to design the components and the production of the car, and then use our TIA portal and integrated automation portfolio to design the manufacturing, and later on used our Siemens Simatic MES software to manage the manufacturing of the car. So this is another great example where we have already deployed solutions to our customers, which they can utilize to run their operations in a manufacturing operations in a more efficient way. Next example is from our own company. This is our factory in Hamburg, which is our electronics factory, where the machines are communicating with the devices, electronic devices we are manufacturing, and running it in a more efficient way. And today, this factory is seen as the Industry 4.0 example, where we are running, in fact, the factory around 75–80% automation grade with a quality rate of 99.9998%, which is excellent. And over the years, by the way, this factory has been again improved, optimized, without increasing the labor force, in fact, keeping the labor force. And today, this factory is running around factor 8 more efficient than before, again, by utilizing the technologies I just have mentioned. Those who are playing golf might know having the right golf club is a key. Callaway is another customer of Siemens. I think in the past, in the last 20 years, they were building prototypes, testing, and then building again prototypes until they have the right version. Since recently, they are using the Siemens PLM software, again, to simulate the performance of the clubs. I mean, they have great people who can design the clubs. But in the past, they had to build the prototypes first, and then test, and build again, which is, of course, a time-consuming and costly operations. Today, they are using Siemens PLM software, running the simulation, the performance simulation, and creating the clubs in a much faster and efficient way. And today's the clubs are much lighter, much faster, and also more efficient and hitting the sweet spot. You might recognize Mr. Obama on this picture. This is Hannover Fair. He was also testing one of the clubs, and I guess he's preparing himself for his retirement time. Short video. All right, some more details about, again, another real case where we have applied our technologies to help our customers to run their processes in a more efficient way. Now, allow me to share a couple of things which we have done here in Taiwan and what we are doing in Taiwan. I think that's very important. This is what we call the future of manufacturing truck, which we have deployed around 2 years ago, 2014. And showcased, in fact, crucial elements of Industry 4.0 at different occasions. This was, in fact, a mobile showroom which we have deployed here in Taiwan, starting with Taipei, and went to universities and customers all over Taiwan, and also showed and discussed with customers, but also students, about the future of manufacturing. In fact, it is one of our contribution for Taiwan here regarding this topic. The next one, very fresh. We have just signed, I would say yesterday, signed an MOU with the Ministry of Economic Affairs Productivity 4.0 office to support Taiwan's development in Industry 4.0. So Siemens and Ministry of Economic Affairs agreed on different areas to cooperate and support Taiwan's industry in introducing Industry 4.0 elements. There are three key areas. The one is the talent development, education, training. The second one is building demo size, respectively, projects. And the third one, of course, business opportunities, which we are addressing together with our local partners. So again, this is another example of what we just recently agreed to do and support Taiwan. Important is, I didn't have any explicit slides that I like to use here. The human factor will remain an important factor also for Industry 4.0. The roles will change, but we will need still humans who can design, who can operate, who can change the operations in a factory which has been established with Industry 4.0 elements. And this is, I believe, is another key topic which we have to also look into and also support the education of our people for the future operations of our factories. And this is, again, another area where we are also working here in Taiwan with different institutions and also bring in training to the schools, to the vocational schools, and help people to get educated and understand how future of manufacturing will look like. This is my last slide. Industry 4.0 is, in fact, an evolution. And there's still some way to go to achieve that level. But we have already many elements I have shared with you in a couple of examples, which began today deploy and utilize. It is an evolution. It is not a revolution. So things will evolve over time. And it's important, the process alignment integration. I have shown you a couple of examples. I need to integrate those different steps from product design, production design, manufacturing operations. They need to be interconnected. And of course, use of digital and integrated engineering tools, as I have shown in a couple of examples, our PLM software, DAY portal, our digital enterprise software suite is in fact the answer for the challenges. So this is important. But we still need to work on certain standardization of automation of hardware software. And we need to have all the standard platforms to run the things, let's say, in a more efficient way, like utilizing our DAY portal or DAY, respectively, Profinet. And also the communication capabilities of machines needs to be increased and improved. Again, we have seen in the first session that we will have great hardware support, sensors, but still there is some way to go to have a better communication between devices, define protocols to run the things in a more efficient way, and this is something which we have to still work on. And last but not least, it's important that we need to prepare ourselves, and if you're running a manufacturing, you need to look for partners, you need to look, educate your people and get prepared for future of manufacturing. In closing, in fact, at Siemens, we do not only talk about Industry 4.0, but also we do it. I have shown you a couple of examples in different areas, but we're also having examples here in Taiwan. We have already started 2 years ago with our Future of Manufacturing track. We have signed agreement with some local companies already 1 year ago. Yesterday we have signed agreement with the Ministry of Economic Affairs, and we will keep continuing and supporting Taiwan also in this important area, what we call Future of Manufacturing. That was it. Thank you very much. Once again, thank you for giving me the chance to present this important topic. And thank you for your joining and participation. Once again, thank you very much.
Thank you, Ardal, for joining us this morning. We really appreciate your presentation and your insights on Industry 4.0, the future of manufacturing in the digital world.
Good on.
And this morning's last speaker will be Rahul Patel, Senior Vice President and General Manager of Connectivity, Qualcomm Technologies. Rahul is currently responsible for Qualcomm's connectivity and networking businesses and leads the wired, wireless infrastructure and networking, and mobile, computing, and location product management organizations. He is a veteran of the semiconductor and communications industry with more than 20 years of experience in product and business development for networking and wireless connectivity solutions. So ladies and gentlemen, without further ado, let us give him a very warm welcome.
Thank you. Thank you. Good morning. Good morning. Good. You can hear me, right? Good, good, good. Thank you for coming in to listen to me, share with you what is the future of wireless world going to be looking like on a going forward basis. And more importantly, this demanding wireless world, how it is going to be needing to be technologically supplemented with certain key aspects to deliver the experience that we all and the consumers are going to come to expect of wireless technologies. As the lady introduced myself, I'm Rahul Patel. I manage the connectivity business for Qualcomm. And what I'm going to start off with is giving an insight into what's happening today in our homes. I know over time things have built up and probably people have lost track of how complex our home networks have become. We've gone from just doing PCs being Wi-Fi connected in the home to televisions being Wi-Fi connected. Now we have thermostats. We have all kinds of sensors, music systems, getting multimedia, audio, video, technology over Wi-Fi or BLE mesh for your IoT networks, and it's becoming very dense. A lot more devices trying to use the same network that we had a few years back. And you can imagine in many countries in Asia, you are going to be in a multi-dwelling where you have multiple apartments in a complex, and it's not just one building, it's many buildings, and you see all these wireless networks kind of operating simultaneously in a very small area. A lot of congestion, a lot of shared medium, a lot of density in terms of wireless technologies kind of in their own network spectrums. 2.4 gig where Wi-Fi is very prevalent, 2.4 gig where Bluetooth and BLE, and then Zigbee, and then you have 5 gigahertz Wi-Fi, you have multiple radio implementations in 5 gigahertz and on and on. You can see it becomes very complex. And the spectrum is fairly limited. It hasn't changed from what it was, over the last 10, 12 years that we have used it in other applications. Over the years, we just kind of jammed in more devices into the spectrum. And magically, the consumer expects everything to work. Everything to work in context of the applications they're going to source, be it video. But about a year back, it was standard definition video. Now, it's not HD, it's Ultra HD 4K video. And it's not one screen in the home, it's multiple screens in the home. You may have a 4-inch screen, you may have a 5-inch screen, you may have a 10, 12-inch screen, you may have a 55-inch screen, you may have 65-inch screen, and on and on. All these screens have certain expectations of delivering a user experience that cannot be compromised. If you compromise, then the user is going to be deterred from the experience, and you may have issues delivering products in these areas. And so our television becomes less attractive because the connectivity, the wireless connectivity in the television is not adequate. Not because the graphics decoding capabilities, not because of the screen size, because of the connectivity. The security system in the home becomes inefficient or not desired because it's not reliable, because the connectivity is not there in the security system. The music system is less desirable if you're not able to stream in harmony, in synchronous to the various speakers you may have in the home. The lighting system is not going to be effective if you're not able to control lighting. Your automobiles, your cars, they're going to have Wi-Fi, BLE. If you're not able to have the latest and greatest downloaded content in the cars, it's not fun, right? And when you come to expect something and it's not there, you deter from that experience and that product as a result. And so the connectivity is becoming extremely important. And as you see in this example, nothing has changed. The spectrum is the same. There's a lot more devices trying to source the same bandwidth that is available in the network. And how do we solve these problems on a going forward basis is going to be key. Having said that, what's Qualcomm and what is the needed approach in the marketplace to solve this complex problem, which from a user point of view is very simple: deliver the experience. Qualcomm believes you need to drive a very holistic approach. You can't be one radio technology centric. You can't be cellular focused. You just can't be Wi-Fi focused. You can't be just BLE focused. You have to have an approach that spans across any and every spectrum, any and every radio technology. It has to be one that's largely built in harmony over multiple radio technologies to deliver three key aspects. Capacity, what that means is more throughput, faster application support, context and experience. Contextually awareness is key. Not every application needs to be supported with the same amount of bandwidth as the fastest application. Not every application needs to be on all the time. Not every application can be just data only. Some can be also derived using analytics. Some intelligence is there. And so you have to develop a contextually aware network so that there is optimality from a user experience point of view. And then the third big pillar, which is technologically very challenging for anyone to deliver if you have one-point radio technology and you don't have access to other technologies, is convergence. How do you bring cellular, Wi-Fi, BLE, Zigbee, 11AH, all of these technologies together and work as one interface to the consumer? Let the consumer not be burdened with making the decisions on what spectrum the consumer is going to be on a going forward basis from a user point of view. How can we make sure that we bring the most cost optimal solution? Because now you have all these things. How can we make sure that the assets that you may have in one spectrum in an implementation in a product are also leveraged by another spectrum radio technology that may be in the platform and not have to duplicate those assets? And you will see some of these things are going to be essential to delivering the holistic experience. Again, it's all about being able to address capacity issues that would make sense, that would be contextually aware from a network awareness point of view, experience awareness point of view, and then leveraging all the assets in the platform, especially the radio technology assets that are in the platform through convergence. So let's look at capacity. What is definition of capacity? Capacity is all about more throughput, more bandwidth to work with. These are the baselines for capacity. Capacity comes through three different aspects. One, more spectrum. You have a lot more radios to work with, a lot more frequencies to play with. Capacity comes with having a lot more front-end design capabilities, antennas. You cannot expect one radio technology to use one or two antennas, another radio technology use another two antennas, because there's not space in the form factor that you may have to deliver into. There's not enough to kind of work with from a cost dimension point of view, right? So leveraging some of these things from hardware capabilities in the platform is going to be key. And then more efficiency. How do you leverage the know-how of what's happening in one frequency spectrum and not kind of burden that spectrum with something that could be done in other spectrum? How could you kind of move applications from one spectrum to another spectrum? How could you balance the network so that the best available spectrums are made available for the right applications? This is what efficiency is all about. Also, one big thing on efficiency, especially on handheld devices, is the battery life experience. Some frequency utilization would use a lot more battery life versus the other. And so how do you optimize for the battery life experience is also going to be key. Net-net, delivering the capacity dimension, you have to be mindful of all the spectrums that are going to be playing in that product. You have to be mindful of all the hardware assets that you have to work with, and you have to be mindful of the net efficiency in delivering the network experience you bring to the table when you are looking at utilization of resources, utilization of spectrum, and also the battery life experience that a consumer is going to come to expect. Let's look at capacity. You know, capacity about a year back with Wi-Fi, 802.11 AC, Wave 1 technologies was largely through the single-user MIMO implementation. Last year about this time at Computex, Qualcomm announced, or was the first one to launch and announce Wave 2.11 AC products. What does Wave 2.11 AC do? It brings in the technology of multi-user MIMO, moves from single-user MIMO capability to multi-user MIMO. What this means is you move away from time division multiplexing every client, effectively sharing the bandwidth versus simultaneously operating in every time slice to maximize the bandwidth available from the access point. What this does is effectively, with the same spectrum that you had to work with about a year back, now you have 3x the capacity. All the Qualcomm products that are launching now and have launched in the last year or so have multi-user MIMO capability in them. More capacity also can come through additional spectrum. Wi-Fi partnered with WiGig, and today, as part of the Wi-Fi technologies, you have 60 gigahertz spectrum. Qualcomm, through its Velocity acquisition a couple of years back, now has a leading 60 gigahertz product line. Through 60 gig, now you have a very high bandwidth capacity, faster throughput PHY technology available. You are going from 1 or 2 gigabits per second to multi-gigabits per second, 4 to 10 gigabits per second in terms of performance. You are also now having an additional spectrum that's a lot cleaner, that is noise-free, not interfered, and available to do other applications which are very sensitive to performance or the link budget. The key applications that come to mind are productivity. Having a wireless desktop where you don't have to worry about having wires connect from your PC to your screen. You're wirelessly docking, because now you have better than gigabit Ethernet, better than USB 3 performance between the two products, basically. You can wirelessly move content from your handheld device that may be coming from one company and your PC that may be coming from another company. And you may have connectors, wired connectors that don't fit very well between the two companies. With wireless I/O application of 60 gigahertz, you can move traffic or files very easily, seamlessly on a standard-based medium or wireless technology like 60 gigahertz. What you can also do with 60 gigahertz is in-room streaming. The world of Ultra HD or 4K is here. You're having to compress over traditional Wi-Fi in 2.4 and 5 gigahertz to get the best experience is not the same as having to do with uncompressed or lightly compressed over 60 gig, where you have multi-gigabits per second to work with to stream video content. This is a huge application for 60 gigahertz. The other big application that's looming for 60 gigahertz is networking. Now with multi-gigabits per second, you can replace Ethernet to backhaul in your enterprise with 60 gigahertz. You don't have to route wires that you would have to do about a year back. With 60 gigahertz, you can get multi-gigabit per second and technology that would do it wirelessly. You can also use 60 gigahertz outdoors for line of sight. So from a pole to pole, access point to access point communication, you could use 60 gigahertz as well. So a lot of good applications here with newer spectrum like 60 gigahertz become available. The second big pillar of the experience that a consumer comes to expect and the technology that's going to make it happen is context and ultimately being contextually aware from an experience delivery point of view, application delivery point of view. What does this mean? Let me take an example here. My friend Emily Chen in Taiwan, she is extremely busy. She's a hardworking professional. She's a mom, and she has no time. She's got a very busy day, every day, including the weekends. She has this thing about the grocery list. It bothers her because she takes time. She doesn't know what's in her refrigerator, what's in her kitchen. Every time need to replenish it, and she doesn't make the right decision if she doesn't have the right contextually aware application helping her kind of do the shopping whenever she ends up in the grocery store. So what does Emily Chen have to look up to? Emily Chen can talk to her refrigerator. It's an IoT device. With the refrigerator communicating to Emily Chen over cloud or through her access point or IoT hub in the home, Emily Chen now knows exactly what's in her refrigerator and what needs to be added to her refrigerator through the grocery list that the refrigerator will help her build in her phone. She now knows there's not enough cheese, there's not enough soy milk. She now knows there's not enough dumplings in the refrigerator so that she needs to go buy it. Not only that, Emily, is very cost conscious because she wants to make sure she does the right by the budget that she has to work with. Emily is also very health conscious for herself and her family. She wants to make sure she's going to bring in the right products into the home that are going to be healthy enough. So what is happening over here? Through being contextually aware in the grocery store network and being contextually aware in the home network, intelligence comes into Emily's handheld device. And so now she knows what is the exact thing that she needs to buy, and she has a very nicely consolidated grocery list in her phone. Not only that, when Emily comes to the grocery store to shop, her phone is going to direct her to the right shelf. There may be 10 different types of breads or brand makers basically on the shelf. Emily has to make a choice. The phone is going to help her make a choice. The phone is going to say, this is the best bread for your family. Not only that, if Emily has to buy a washing machine soap, for example, it's something that's not perishable. And the phone is going to tell Emily that this is what you need, but this store that you are in does not have the best price proposal for you, does not have the product on sale. Maybe something online, an online store, has it available for you, and it is probably at a discount than what you have in the store. And as a result, from the handheld device, from her phone, Emily can make a purchase and something gets delivered home. So here is Emily Chen's contextually aware network at home, in the grocery store, coming to play and making her life a lot more productive as a result. In summary, in any contextually aware network, what do you expect for a consumer to expect from the network side of the experience? You expect the consumer to see decision making that is going to be somewhat autonomous, individual oriented, focused on the individual. It's actionable, it is quick, it is inferring the context of where that person is. It is inferring in the context of what that person is wanting to do, not only from a location point of view, but her choices, in this case, Emily Chen's. It's going to be also important that the application continues to develop a database and ultimately the right analytics to build on so that the next time Emily Chen or a consumer walks into any contextually aware network, be it in your home, be it at your work, be it in the mall, be it in a movie theater, be it in a traffic jam situation that you may be in, you're looking for the right restaurant, you get the right decision making available to you. At the end of the day, it's a consumer's choice, but you have a lot more data and a lot more intelligence in that decision that comes your way as a result of utilizing a contextually aware network. Technologically, what has Qualcomm done to make this thing happen? A couple of weeks back at the 2016 Google I/O, it's a big Google conference that happens on an annual basis, Qualcomm introduced the always aware, contextually developed hub. It's not just a piece of silicon that has a certain processing capability, but it is a very low power DSP engine. It is an engine that has the ability to assimilate various scans from Wi-Fi, BLE, and other radio technologies that may be in the platform to develop that context, the neighborhoodness of, or the proximity of the location that you may be at. Do it in a very low power manner, completely offloading the apps processor and doing it all in the silicon. Further, it is going to utilize multiple networks. It's not just tied to one network. It may utilize your 3G network, your 4G network, Wi-Fi network, BLE network, what may be available and what may be best suited for that particular application. It's also going to utilize all the sensory technologies that may be in your product or in your platform. Be it your step counter to get the accuracy of where you need to be it your XYZ axis, accelerometer, your height, your location in a building, all these things will come to play as a result of this technology that Qualcomm is bringing to the marketplace. So in summary, what is the network-centric view of being contextually aware? You have to be able to have access to all kinds of technologies that may be in your platform. You have to have the ability to access all kinds of technologies, radio technologies especially, that may not be in your platform but may be around you. And you could be potentially leveraging that information to develop the right location and monitoring of the environment. It could be Wi-Fi, 2.4 gigahertz, 5 gigahertz, 11AC, 11N, it could be 11AX on a forward-looking basis, it could be BLE, Bluetooth, it could be LTE, it could be other things that are in your platforms in the home or enterprise. It has to understand all these networking technologies so that it can make the right decision based on the needs of the application. It could be improving the battery life or optimizing for battery life experience, optimizing for speed, quick decision making, the latency. If it is video, you want to make sure it's not lagging and it is delivering the right experience. A lot of things. And at the end of the day, you also don't want to compromise in security. Again, this thing has to be something that is going to be actionable. It has to be something that's going to be valuable to the end consumer when all is said and done. It has to be on 24/7. Whenever you turn on your device, you need to be able to come up with a quick decision based on all the data that device has gathered over time and at that particular moment where you may be in the network. Qualcomm, earlier in the year, introduced the self-organizing network over Wi-Fi called Wi-Fi SON. Through its experience with ultrasound in the cellular network, Qualcomm brought in the self-organizing network capabilities into the home. Today, an average consumer is challenged in terms of using Wi-Fi because they have to worry about security of the network. They have to worry about the network being there all the time. They have to worry about what bands you connect to. These are all technical decisions that the consumer is burdened with. With Qualcomm's Wi-Fi SON, now you are able to kind of deliver four-pillared experience on the platforms that Qualcomm would ship. This would be about helping the consumer self-organize the network. The consumer has now no intervention. The network self-organizes. Self-managing, that is, if the performance needs to be optimized for a video experience, for download of a file, or just browsing of the internet, the network will optimize for simultaneous experience and performance in the network to deliver the most optimal application experience at the viewing screen. Self-healing is another key aspect. Today, not all Wi-Fi networks operate in the best of the capacities. Sometimes there is interference. As a result, how do you kind of move the consumer to the right network, make the right choices for the consumer? It's going to be key on a going forward basis. And then obviously security and defending against network attacks and making sure the consumer who is unaware of the network is kind of moved to an area of the network where they are less susceptible to some of these challenges of network attacks. So self-defending and self-reconfiguring to deliver the best experience is going to be key. Qualcomm, through its Wi-Fi SON, working with a lot of customers of its OEM customers and ODM customers in Taiwan have already started shipping end products in the marketplace with Wi-Fi SON. So if you look at Wi-Fi SON as one big example, and then combine that with contextually aware applications and delivering all those things that I just talked about in the earlier slide with Emily Chen and her grocery shopping experience, you can see there's a lot of network-centric view and technology that comes to play. There is also a user-centric view and the experience in the handheld device that needs to come together in a way that you deliver a holistic experience for contextually aware networks. The third big pillar of the holistic approach that was capacity, contextually aware network experience, the third one was convergence. And so from a convergence point of view, it is very loosely used in the marketplace. What you see is a lot of people talking about convergence. From a Qualcomm point of view, convergence means largely convergence on device integration, convergence on managing the resources most optimally in the platform, all the resources that you have, and then bringing convergence at a platform level. What does device integration do? What device integration does, it's kind of reduce the BOM, which is very critical to a lot of the OEMs and ODMs in Taiwan. It effectively helps improve the cost. It also helps bring the power dimension to life basically in a more optimal manner. What does resource aggregation do? Resource aggregation makes use of the spectrum most efficiently. If you have multiple spectrums to work with, if a single product company comes to play, they would be focused in one spectrum. With Qualcomm, having the ability to be in Wi-Fi, in cellular, in IoT networks, we are able to kind of leverage all the spectrums that may be available in the platform, and as a result, deliver the best experience by moving clients from one spectrum to another, depending on the availability in every spectrum that we may have to work with. And then platform convergence. There's a lot happening in the world today. I know in Taiwan, a lot of the television, the traditional set-top box television play is now getting into the over-the-top video or Wi-Fi delivered to the screens. Similar is the case in the Western world in North America. In my own home, I was just comparing my AT&T usage. About a year back, my home was consuming about 200 gigabytes of data on a monthly basis. This month, or the last month, I was at about 600 gigabytes of data. And it's the same size family, it's the same number of devices, but a lot more video content is coming in the home. A lot more, things are happening over the networks. Effectively, in my own home, the network capacity or the network sourcing is now 3 times more than what it was about a year back. And I'm sure it's the case in many homes around the world. Platform convergence is going to be key. Having a home where you have a router device, you have an IoT hub, you have a small cell device, you have many devices, infrastructure devices in the home, is very confusing. Having a converged platform where you have broadband, like DSL, PON, Wi-Fi, small cells, BLE mesh, IoT hub functionality, all kind of developed and delivered in one platform is going to be key on a going forward basis. Because from one platform now, through the right software, firmware access, you can make decisions that would be optimal for the network. Effectively, another way of convergence playing a big role at the infrastructure side, on the hub side, on the one infrastructure that you would have in the home through convergence as a result of multiple products kind of getting integrated into one product. If I kind of have to summarize what is LTE and what is Wi-Fi, and if you look at the maps of Beijing and you look at the map of Hong Kong, LTE is like the map of the infrastructure roadways map of Beijing. Wi-Fi is like Hong Kong. LTE is a lot more organized. LTE is a lot more predictable. Wi-Fi is in small chunks basically deployed, but there's a lot of deployment of Wi-Fi, and there's no manageability between the two Wi-Fi networks that may be sitting next to each other because they are autonomous, they are individually designed, they're not designed in a way that is going to be looking at the entire infrastructure like LTE would be. Convergence brings the best of the worlds together. You get the flexibility of Wi-Fi, but you also get the organization and predictability of LTE as a result of bringing LTE and Wi-Fi together. So through convergence, you could have a lot of things come together. You could have your broadband PHY technology, maybe it's DSL, maybe it's fiber, maybe it's cable, maybe it's LTE. That's where you get your broadband from. Combining that with the in-home delivery on a forward-looking basis, all the content that comes from the broadband network is going to be largely delivered wirelessly to every screen in the home, be it a 4-inch, 5-inch screen, or a large screen like 65 inches, like a television. You are going to get content delivered using wireless technologies. Convergence at the platform level, optimizing at the PHY, be it the broadband PHY, in working in symphony, in concert with the PHYs that are going to be delivering content to the screens, and also taking into account what's happening on the PHYs in the screens is going to be key on a going forward basis. Convergence is all about bringing all these PHY technologies, all these radio technologies, be it at the infrastructure, be it at the client side, together and delivering the right experience. And then being able to also manage the delivery of the experience through the cloud, giving the service providers access to, the dynamics of the home, the dynamics of the home in context of the various clients that may be in the home, the dynamics of the home in context of the neighbors that are surrounding that home. This is very crucial information that the service provider would benefit from. And so bringing that information back to the service provider and managing through the cloud, the delivery of the experience is going to be key on a going forward basis. And convergence plays a huge role on a going forward basis. Having said that, building an end-to-end ecosystem is key. Be it a PC maker like Acer ASUS in Taiwan, or be it a router maker like ASUS in Taiwan, or ODMs who are partners of Qualcomm, bringing the OEMs around the world like Netgear and D-Link and TP-Link, and the enterprise OEMs like Cisco and others in the marketplace, the right experience, be it the phone manufacturers like HTC, ASUS, or some others that are being supported by the Taiwan ODM base around the world. It's going to be key. You can expect Qualcomm products to deliver the end-to-end experience around the 3 pillars that I just shared with you: capacity, being contextually aware, and being able to leverage the benefit of convergence technologies in these platforms. Thank you very much.
Thank you very much, Rahul, for joining us this morning. With that, ladies and gentlemen, we conclude the keynote session on future technology. 今天早上的议程到此暂时告一段落。我们也想要提醒在场的贵宾，您可以在您的名牌的后面看到一个 QR code。那么用您的手机扫这个 QR code 的话，就可以填写线上的问卷。那么凭完成截图，可到报道台兑换数位时代周刊1本。May I also remind you to please take a few minutes to fill out the online questionnaire for the conference. You will be able to access the questionnaire by scanning the QR code on the back of your name badge with your cell phone. Your response and feedback will help us improve the quality of our services. May I also remind you that the CPX Forum on IoT Ecosystem Partnership will take place at 2 p.m. this afternoon, and the doors open at 1:30. Once again, thank you so much for joining us this morning, and we hope to see you at the forum this afternoon at 1:30 p.m. Ladies and gentlemen, good afternoon. Welcome to the Computex 2016 CPX Forum. 各位长官、各位贵宾，欢迎莅临 Computex 2016 CPX Forum。今天下午的议程即将要开始，我们请您将手机调为震动模式。那么我们也可以提醒您，您可以看到您的名牌的背面有一个 QR code， 您可以用你的手机来扫 QR code 来填写线上问卷。在今天下午的演讲听完之后，我们邀请您来为我们写线上问卷。凭完成截图就可以到我们的报道处兑换数位时代周刊一本。我们请各位贵宾在今天听完演讲之后，能够上网帮我们填这一份问卷。谢谢大家。And ladies and gentlemen, this afternoon's program will begin here in about 2 to 3 minutes. We would like to ask you to please be seated, and we would also like to remind you that please take a few minutes to fill out our online questionnaire. You can access this questionnaire by scanning the QR code on the back of your name badge with your smartphone. Your feedback and responses will help us improve the quality of our services. Once again, the program will begin in 2 minutes. Please be seated. 各位长官、各位贵宾，下午的议程将于2分钟后正式开始。我们请各位贵宾尽速就座，谢谢。 Ladies and gentlemen, welcome to the Computex 2016 CPX conference. The Internet of Things is all about the power of connection. Fulfilling its promise requires collaboration and partnerships. Today's forum will explore how the industry is harnessing a wide range of expertise and abilities to speed up the development of IoT while enhancing the IoT value chain. Ladies and gentlemen, to kickstart this afternoon's program, I would like to invite Thomas Huang, Deputy Executive Director, Exhibition Department of Taitra, to deliver his welcoming remarks. Let's give him a very warm welcome. Please welcome Thomas Huang.
Mr. Dubey from Cisco, Mr. Chung from SoftBank Korea, Mr. Wu from Ericsson, Mr. Samuels from Amazon, distinguished guests, ladies and gentlemen, good afternoon. On behalf of Taitra, the organizer of Computex and the CPX conference, I would like to welcome all of you to this session on IoT ecosystem partnerships. And I would like to thank all our speakers to travel a long way to be here with us today. In the era of IoT, which we all belong to, the partnership in the ecosystem is necessary to work out any applications in IoT. Therefore, this year, we gave this year's Computex a new positioning, which is building partnerships in internet computing ecosystem. We created two new areas, which are the smart techs for IoT application and the Innovex for startups and innovation. According to IDC, the Global Market Research Institute, 50% of IoT solutions are created by startup companies aging less than 5 years. So this year, our goal is to provide a platform for Taiwanese industry and the global ICT industry to build partnerships with each other. Today, we're honored to have our outstanding guests with us, and they are going to share their perspectives in the IoT ecosystem partnerships. And I believe their insights will be beneficial to all of us, and I wish you all an informative afternoon. Thank you.
Thank you, Thomas. Thomas, we would like to ask you to please stay on the stage for group photo shooting. And now we would like to ask all the keynote speakers and presenters in the afternoon to please go on stage for group photos. Ladies and gentlemen, please welcome Martin Dubey, Managing Director, IoT Solutions Sales, AP&J in Greater China, Cisco. Vincent Chun, Managing Director, SoftBank Commerce Korea Corp. Howard Wu, Vice President and Head of Product Line Software Defined Infrastructure for Business Unit Cloud and IP, Ericsson. Last but not least, please help me welcome Dean Samuels, Solutions Architect Manager, Amazon Web Services. We thank all the distinguished guests who have taken time out of their very busy schedule to join us this afternoon. We look forward to hearing their presentation and their insights. We ask all the distinguished guests to please put your thumbs up. Thank you. Thank you very much for joining us. And today's first keynote speaker will be Martin Dubey. As a respected AP&J sales leader for the enterprise business, Martin is currently working as the AP&J Managing Director for Internet of Things at Cisco. He is responsible for an Internet of Things specialist sales organization, driving value and sales, and managing high-growth strategic priorities for Cisco. So ladies and gentlemen, without further ado, let us put our hands together and welcome Martin on stage.
Good afternoon, everyone. I really appreciate the opportunity that I'm here today, and also appreciate the opportunity for all of you being here. I know you're very busy in your schedules, and also like to thank also Computex for allowing Cisco to be here today in our presentation. So a few things I like to start with. I usually like to start with if your organization is actually a disruptor, or you actually been disrupted. It's quite key to understand this because there's about 40% of the top 500 is actually going to be disrupted within the next 3 years due to the new age around digital. So a lot of you are probably aware of around Uber, some of the disruptor. They're basically the largest taxi organization without owning a single taxi, providing a lot of challenges in terms of disruption. You also have WhatsApp's actually created a lot of disruption within the telcos. You have Alibaba, the largest retail store in the world, without owning a single retailer. And then you have Tesla, a car manufacturer, but basically providing disruption within the battery industries. So key things around some of these 40% that is quite interested to know is that that's going to happen within the next 3 years. The top 500 companies that are there is actually going to be disrupted, and there will be some change with some of the startups. So for example, if I talk about the startups within Asia, Pacific, and Japan, out of the top 20, how much basically Asia would be worth is basically $132 billion of dollars actually provided. How much basically, what are these organizations if I put some of the top 5? These are right in your backyard. These are the top basically, some of these new startups actually coming in, if I have put in like Compound from, for Korea. But how much basically funding have they received? This is another area. They basically received $18 billion in terms of funding. They were able to reach out. And what basically in terms of revenue, what size are they? They're quite large when you look at them in terms of size. In terms of basically some of the total funding they receive, also quite a large amount of funding they receive. And where are they positioned in terms of the top 500? These are their position in the top 500. And they startup organizations, so it's quite key to understand the disruption that's happening, startups that are coming in, so you could understand where and what it's actually coming in our own backyard within Asia Pacific and Japan. If you look at some of the banking in terms of where the banking as an industry will be going into, a lot of it will be around digital cash. And we're not talking years ahead, but I'm talking around 95% is already within Sweden actually looking into cashless. If you look into the retail, if you look in terms of the way that things are going in terms of retail, a lot of it is very close to the consumer and the manufacturer, squeezing in the retailer in between. Because where things are going is they're reaching out in terms of co-innovation. They're looking also in terms of how basically they could get from a product from a consumer side and connect it as close as they can to a manufacturing plant. And these are not 10 years ahead. These are things that people are looking into within our region. If you look into the manufacturing, robotics coming in, there's going to be a big impact, and you're definitely aware of this in terms of manufacturing plant. I was in Indonesia last Friday, so if you could go very, very quickly. Last Friday, and 18% of the labor in the manufacturing plant actually went up, but the productivity stayed the same. So there are many manufacturing plants basically losing some of their own employees to go through other plants in terms of competition. At the same time, there's not too many university grad coming out saying, I'm going to go work in a manufacturing plant. The robotic age is coming very closely and very near to Taiwan. So you already know that some of these things are actually happening. Now, if I just basically play into a video, what's happening in the sports industry.
Over 1,700 times during a game. But what happens in between a bounce? Over 15,000 fans are inside the arena. 754 of them are watching the previous play. They didn't agree with the referee, but only until they checked camera 4. 257 are more concerned with what to eat. Hot dogs are outselling burgers at a 2-to-1 ratio. More than 12,000 transactions are being processed. 178 screens are talking to fans on the main concourse, where 367 are finding the fastest way to the bathroom. Back here, 12 cameras are generating 2,000 gigabytes of data, which thousands of servers are sharing, with millions of fans around the world. And that's just one mouse. Cisco and the Internet of Everything are making big even bigger.
So who was to know that a stadium would actually be connected to a data center? Who was to know that you would be actually connected as a fan, able to be connected down to a camera in terms of the field? Who was to know that in the field, the stadium actually want to make more revenue on seat for the customer and able to expand that outside in terms of reach? There's new market, and that's a new market for Internet of Things, where it's actually connected today, and there's stadium across Asia Pacific and Japan and other places also around the world that are already connected in that place. So it's not something in the future, it's something that is now, and that's in the sport industry already happening. So IoT is actually a key enabler, not just in the sport industry, but also in the manufacturing. If it's a smart manufacturing, if it's on the retail side, if it's basically in utilities, or even into the transportation, it's actually enabling across the verticals. By 2020, we estimate there will be about 50 billion devices actually going to be connected. With that, would require a lot of data that actually will be connected in this area. So let's just show how it's impacting in the manufacturing organization. So what we basically have done is we've connected robots. We've connected actually robots in that place in order to enable the manufacturing plant. But not just robot, but also the machinery. If it's basically a sponge, basically one that will be punching, or if it's actually cutting, in order to connect to the sensors from the beginning across the value chain, also in order to have the connected factory. And why is that happening? Is that there are a factory in a country, in Korea, for example, one of the manufacturing plant in China is yielding bigger than this yielding in Korea, and they don't know why. And they were looking into how can they understand which manufacturing plant is actually yielding the most, and how can they drill down at the top. Same manufacturing, producing the same product, same machinery, same amount of people, but not yielding the same. How can you go from a manufacturing plant down to machinery, down to process with the tools around it in order to see where the yielding challenges are? And this is where things are coming in with the Internet of Things. Already happening, already connected, and already basically optimizing the robot and the machinery. In order to prevent, you need to predict. Once you're connected, you're able to see what's coming up, and you're able to see some of the challenges, and you're able to keep the plant running in that space. So, and at the same time, you could also save power once you understand what is running. So let's see what's also happening across different verticals within the Internet of Things.
The Internet. Once here, now it's suddenly everywhere, unleashing a world of opportunities. The Internet of Things. It's already here, in cars that drive themselves. Here, where gate sensors put fans in their seats faster. Here, bringing doctors and patients together virtually. Smart buildings are already reducing energy costs here. Drones use infrared imaging to detect crop failure here, while sensor-driven pumps conserve water here. Networked sensors and cameras let students in and keep trouble out here, while smart vending machines personalize the shopping experience here. The Internet of Things is cutting unscheduled downtime here. It's turning data into profits, streetlights into guardians, and mines into safer, more profitable production centers. Here, millions of containers can now be tracked in real time from a single location, while connected emergency vehicles turn the lights green here. And playgrounds are now safe places to play here. Welcome to a world of things, already making a world of difference in so many ways, in so many places. Where will you take it next?
So part of my job is actually to be going across all of Asia Pacific and Japan, inclusive of Greater China, across all vertical. So I spend my time, most of the time, within different verticals. And actually, when I say verticals, is basically different industries on their site within the OT environment, if it's manufacturing, or with the smart cities, even here within Taiwan, what sort of the directions are going, which I'll speak a little bit further. But it's actually happening today, and that's why it's quite an environment to look into. It's not something in the future, but it's actually happening today. So when it comes to basically two eras around the digitization, is you have the IT era, basically the mainframe in the 60s, you have the PC and the web. In the 80s, you had the cloud and mobile in 2005. And from the 15, you had a lot of already happening within the IoT, already started within around 2013. From innovation in terms of driver, you have the enterprise, the consumer, and all within the digital space moving into. So there are two eras running side by side. And then when you start looking into, they are connected in terms of way it's actually going for your business. So when it comes to digitization, it's all about data-driven from an organization. If you basically, all the organizations are looking into data in order to enable their business. It's all account-based, and it's basically continuous innovation or co-innovation in order to continue inventing, in order to compete, in order to continue in that market. And it's a moving fast market. When you look into the center in terms of transformation, in terms of transition, it's all around basically connected. It's all in terms of centers connected, which if you're looking into automation, you'd have to connect to, in the back end of that Internet of Things, there would be some mobility. There would be the cloud. There will be the big data analytics. If you're thinking of 2020 is not that far out, 50 billion device, this environment of data that's coming in order to react. There'll be that information coming in. So this is an area where you need to be prepared before it hits the cloud, and also the social media in terms of collaboration, and the security is quite key. Security is quite key. I mean, I know this morning Arma spoke around this also, not only within the car, but in the plant. The most attack in today's in terms of security, even Cisco being in that place in our plant that we have in Malaysia, is around security. Once you connect a device or a robot or your environment, as soon as it's got an IP address, it's ready to be attacked. So you need to think putting that security around that to make sure that all is secure. Doesn't mean you don't do the Internet of Things, doesn't mean that you don't connect, but you need to have that in your plan in terms of strategy. Extremely key, so the plant doesn't get attacked. Even today, without being connected, there's already huge amount. It's the place where most hackers are looking into, try to get into a plant. And that we could say for ourselves in terms of our Malaysian plant, like as I mentioned. So let's show what's happening in smart cities.
Here in Hamburg, they have all the ingredients for the Internet of Everything. They have a great infrastructure and one network. They're very well known around the world as the second largest port in Europe. Perhaps they're going to be the first. The port of Hamburg is one of the economic strength. 10,000 ships a year come in and go out. They have one network for collaboration, connecting people, process, data, and things.
The Internet of Everything is the critical enabler for the future.
In that partnership between Hamburg and Cisco, there is a revolution coming, a digital revolution.
Hamburg is very keen with a smart city concept to improve quality of life for the citizens, but also to create an environment where they can stimulate innovation, generate economic value and competitive advantage.
The concept of smart city will really help the citizens having a better quality of life. Information coming from the detectors, which are embedded on the streets, could be sent directly to the center so that the port road management operator could really monitor traffic flow and could take reaction in the proper manner.
We connect moving bridges with traffic management to increase the traffic flow in the port. When a ship is coming, that bridge will open. You can reroute the traffic to another road.
I think that Hamburg is really going to develop as a seatropolis.
We have the challenge to get more containers through the port of Hamburg. The technology is the main enabler for this opportunity.
We have GPS sensors in this container terminal. This kind of smart control operations could really optimize workflows and capacities.
With Hafen City, we are developing the most important inner city project. It is expanding Hamburg by roughly 40%. We are trying to increase the efficiency of car use and of other devices of individual mobility.
We have sensoring spots on the parking lots, so you get directly on your smartphone if the parking slot is already occupied. The Smart City initiatives really help the operations in the city.
Hamburg can act as a stimulator for cities in Germany and across Europe to come up with a similar innovation and have leaders stepping up to drive the concept of Internet of Everything and the digitalization of their business.
We make a contract with Cisco in mobility, in infrastructure. I am quite happy and a bit proud that we are in a partnership with Cisco, and it is important for both of us.
So when it comes to smart city, I've shown the one in Hamburg, but if I was going to talk to about Asia, we already implemented smart cities in Korea. We're already at the Smart Nation in Singapore. We're already in Australia. And we're already spoken to President Xi in November last year. So if you've seen the announcement, there's in there around the MOU. So we are talking into ways to look to enable Taiwan to go to within the smart cities. We've also been with different countries within the region that I can't announce today, but we do have videos that are here. So it's not Europe, it's not Americas, but I'm talking about Asia already implemented, and we have open tour. The sensors on the ground, on the street that you've seen in Hamburg are built in Korea. So the actual sensors around the city itself, we've had them also within Korea. So the key thing about Hamburg is that they had a problem around transportation. It's not just a technology problem, but they had transportation challenge with the trucks and the containers going in, which would cause a massive jam within the cities. And they were unable, in order to see how can they optimize the jamming in this area, would cost a lot of business funding in order to enable that. Once we basically optimize the smart city in this area, we're able to direct the truck. There's actually a call center out there actually directing the truck where there's traffic jam. And before, the drivers used to drive straight to the port, and then there would be a full lineup of trucks that would block the entire city in terms of jam in this area. Now they're able to bring the trucks, the container, when the ship is ready to pick them, and in order to get the ship to go across. The challenge we had today now is the truck drivers were a bit bored because we had set up some parking slot where they could wait without jamming, and in order to so they're not bored, of course, we provided them with some Wi-Fi. And now the city itself, also in terms of pollution gaps that they had, traffic jam that they had, able to see where some of the hotspot and the retail environment and the city itself center is operating a lot faster because they do not have those traffics that they had in the past, and able to see the environment and also able to save costs in some of these areas in terms of operating a city in this area. And when I talk about smart city, I'm talking about transportation, I'm talking about bus, I'm talking about MRTs, I'm talking a full city itself from a smart campus down to a transportation in this area. So the connected in terms of when it's connected, it connects your light, it connects your traffic, it connects your parking. So that means as you drive in a city, you're able, if you have an automated car, if we're there, your car be able to see which spot from the parking meter is actually available. Instead of turning 5 times around the city, it could go directly there and park within, because the parking meters will be connected, and they will be able to save and also allow it so there's not so many traffic jam. That's just one area to provide some of that benefit. And it expand to university campus, because a city is like, they also have mini city in terms of smart campus, which are either universities, and the same can be applied within those. And you could share this within, that's why it's important that you have a government involved, because this can be shared also within tourism, retailers in terms of this area also. So when I spoke about smart cities, think about this. You have the factory that will be connected. You would have the highway. You would have the hospitals. Hospitals are moving down that path. Ambulances are moving down that path. You even have cameras in the ambulance that are connected to help sometimes the doctor or the nurse within the ambulance itself to help along the way. So the full environment spectrum is actually moving down that path. So there's this where I wanted to highlight at the beginning in terms of disruption, where things are moving, and it's moving fast, and it's a technology that's moving fast, but it's already connected in terms of this environment. And then once you have all that data coming out, it's not about storing it into storage, but it's also capturing it at the edge. So what we have also is we created fog. That means, think of fog in a way that if you have a smart device on your wrist, it does not go directly to the cloud. It will go to your phone. And the phone is a fog device that capture and then send only a certain amount of information to the cloud. The same when you have thousands, billions of devices coming in, it needs to be filtered and captured at the edge and live in order before to be sent to a cloud itself, like a plant would have basically a fog environment before going to a cloud environment. So when you think of connected thing, if I could leave some of that message before completing, is that a lot of people want to go straight into the connected ecosystem. They want to be connected straight away, and they'll just want to connect everything because they want to be like most organization wants to be. But you have to think of a strategy. What is it that you need to connect? What is it that you want to predict? What do you want to prevent? How do you want to compete? What information do you need in order to enable this environment? A machinery connected is good for the engineer because he or she can up-yield the machinery. It's not to be sent to the office at the front. So you have to think where you want to be connected, what is next. So you need to start from that point. And then you move to a connected service. And then you move to a connected ecosystem, which basically the plant, for example, and then you have the machinery, the tools, the person, the process, which the Industry 4.0 can be applied in that area. The fleet management all the way down to the consumer. You have to think of the full value chain in terms of impact. And this is where I've highlighted around, you need to think around real-time visibility in order to react, and also to really think about the connectivity, security, or some of these areas here. I was in Taiwan in November, and I had 40 manufacturer plant in a room, and I've asked how many was Wi-Fi in their plant, and 80% of the people were not Wi-Fi connected yet, but want to be, and it's moving. That's November last year. And I was here for the smart cities also at that time, and I'm coming back quite often to help the manufacturer in this area in terms to enable them to go down that path in Taiwan. But we need to start on the connecting things, and this is where you need to think in terms of an OT. It's not a technology, it's not an IT project, it's an OT project, and you need to have the OT and IT merge. Sometimes the IT never want to note a plant itself. So they need to merge in order to enable that digitization in terms of going forward. So fog I've highlighted very quickly. Fog is before cloud. It captures the data coming from the device at the edge point before sending it into the cloud. And it's only capturing a certain amount, so you don't have tons of information going in, but just the data that you could actually act on, which is a technology that we've built and running in today's. So if I could leave you with this slide, in terms of things that you would need to think in terms of your strategy, think about the connectivity. Security is key. The fog in terms of environment, the analytics, what you're going to do with the data, who's going to use it, the management in terms of automation, and the application enablement. And I wanted to just to highlight is IoT is real, so it's big, it's different, and it's now. Those three things, if you could think about those three points, because it's not something that I'm talking about the future, but the things that are now, and there are many reference sites in the region for all verticals that you could share and see with partners that are in the room here, and also see in live, if it's smart city or manufacturing. So I'll leave you with this slide. I know it's fast. My language is not English, but we connected in English, so that's a good thing. We're able to connect. So I spoke, maybe I've been fast, but if you need to connect and have some more information, just send me an email and I'll be happy to connect with you. So again, thank you very much for your time. I know it's a busy schedule, and enjoy the rest of the week.
Thank you very much for joining us this afternoon, Martin. The next speaker will be Vincent Chun, Managing Director, SoftBank Commerce, Korea. Vincent has over 25 years of experience in the mobile and telecommunication device industries, ranging from startups to multinational companies. And he is now working at SBCK Corp, a subsidiary of SoftBank Group in Korea, as a managing director responsible for IoT business in Korea and global market opportunities. So ladies and gentlemen, let's welcome Vincent Chun.
Okay, thank you very much for inviting me to this wonderful conference and have a chance to share some viewpoint of IoT ecosystem and partnership and marketplace. I was somewhat surprised and impressed with the former speakers Martin's presentations, and it really described our upcoming fourth generation of industrial revolution. And I think this fourth generation will come very quickly and destructively. That means the founding technologies already existed, and the only problem is some tipping point to change everything in this society and the cities and the countries. And SoftBank is not tech companies like Cisco, not chipset makers. We are just carriers in Japan and some distributing businesses in Korea and North America. But we are following the innovation and the revolution of internet era, and now we are facing fourth industrial revolution. So this is somewhat brief explanation of our SoftBank Group. And last year, chairman of SoftBank Group, Masayoshi Son, announced SoftBank 2.0. It included three major business areas which will lead upcoming 30 years of SoftBank business. The first one is AI. The second one is smart robot, and third one is IoT. All of these three business fields are closely connected with data and big data. IoT is very critical to gathering data, and AI is analytics tools for big data, and smart robot will be a kind of some tool to respond to the people's based on the analytics. So I'd like to emphasize our big focus on IoT first, then explain two agendas. First one will be kind of some IoT platform sponsored by SoftBank Group. In IoT world, the biggest difference between pre-IoT and IoT is data. For example, televisions, reprisers are not gathering data. They are just providing services and sending some information. But in IoT, the main purpose is data gathering, and the meaning of data is to solve some consumer's problem. And we need to provide solutions and services to solve users' problem. That's the core concept of IT, we think. And in this IoT business, the monetization will be a big problem and challenges. With this kind of different business approaches, device manufacturers should change the whole of their business schemes. For example, they have to design new services based on their existing technology, and they have to find a customer base and the channels, and they have to consider about how to monetize and how to build their recurring revenues and retain customers again and again. And for retailers, there's another challenges. Retailers can handle huge numbers of IoT devices, but the market is still in early stage and need to find some killer product and services to retain the customer base. So SoftBank is sponsoring a space IoT ecosystem. This ecosystem is mainly sponsored by Brightstar. Brightstar is 100% owned in the SoftBank group, has a presence in North America and worldwide as a distributor of IT product and the mobile devices to the worldwide. And especially, Brightstar is serving for carriers in worldwide. They are providing mobile phones and the solutions and services. And the key is our technical partner for IoT platform. Key is developing Cloud Hub, open API solutions for device vendors. So Key can help all of device vendors to transform their existing business into some IoT services based on cloud. And Brightstar will help you to find live partners and marketplace in worldwide. Brightstar has very close relationship with carriers and knows the objectives and needs of carriers and retailers, so can deliver that kind of feedback to the participating members of device vendors, and that can create real chances, tangible chances for sales and marketing. And the benefit of a key benefit of a space ecosystem is we can provide channels and sales opportunities to vendors through Brightstar channels, and the retailers, carriers can find a single source platform and the full category of vendors and services through the space ecosystem. And end users can solve their real problems using these ecosystems solutions and product. Brightstar has is serving for over 200 mobile network operators in worldwide, and very close relationship with lots of ODM partners and operators. So we can utilize that kind of global presence in this ecosystem. Actually, Brightstar has offices in over 15 countries and serving more than 100 world. And the Space IoT Open Consortium was launched last year, and already we have good partners in the consortium, especially from Japan and Korea and China through SoftBank networks. Yeah, Space will provide a kind of some open IoT platform sponsored by Key. And this space ecosystem can support all devices with a single gateway. And Open API can combine that devices with solutions and develop the target solutions to the end users for solving the customer pain point. So this single IoT platform can be a whole systems and solutions for all of the IoT vendors. Benefit of our IoT strategy is this. With our Cloud Hub, consumers can purchase the devices once, and once obtained, the customer users can be a pool for the recurring revenues and the repeated upgrade, and then returning customer. This kind of 3R situation and strategy is our key benefit. And let me illustrate this kind of multi-source business model. For example, we can get one-time payment for hardware sales initially, and we can sell some upgrade or some add-ons. And then in the service model, we can ask monthly billings and monthly revenues, and we can collaborate with carriers for getting network connectivities. This is quite similar with Apple's strategy. Apple is selling mobile phones under the collaboration with the mobile carriers using subsidy and installment program. And they are selling accessories in very expensive price. And then they are selling some apps in their app stores. And they are collaborating with the carriers. So that kind of some multi-source business model should be applied to the IoT business also. And this space ecosystem will help all of the vendors to participate in that kind of business model. Let me explain as some examples, like a niche market with elders and kids. We should start the problems of our consumers. And for elderly people, they are suffering from Alzheimer's and dementia and fears about for the wonders, and family members are worrying about their situation and conditions. And for kids, they are always in the fears of missing. So from this kind of problems, we can suggest solutions for elder cares that monitors everything, and then the information can be sent to the family members, sons and daughters, and elder care service companies. And these kind of services can be operated based on the monthly fees and the revenues. Another example came from kids. We can design and develop kids tracker, which can be sold as a one-time device, combined bundling with the service per month. And then we obtain the service group, customer group, we can propose another additional accessories with some add-on bundling and the services. So this kind of concept, different concept, is quite critical to all of IoT vendors. This is a final slide of a space ecosystem, and I'd like to emphasize the importance of partnership again. Nowadays, there are so many IoT device vendors and startups in Korea, but they are still focusing on the sales of their device, and they have some brief services based on their application, but not connected to the cloud and not connected to the partner's business plan. So I think the transformation of business concept and idea is quite critical to get the right partnership in good ecosystem. Just second, I'd like to explain some marketplace for IoT devices, especially targeted for Japanese market first. In IoT marketplace, we are still suffering for the low demand and the supply, and still in the early adopter market, not moving to mainstream yet. So market is so fragmented, and requirement is so different in each different countries and different market. So we believe for IoT devices, we need some specific marketplace to handle this kind of problem. So in Japan, we launched ProStyle website. It's an e-commerce platform, just launched in the end of March. And initially it's targeted for Japanese market, but has planned to expand to APEC and other countries later on. In this ProStyle, it's somewhat similar with Kickstarter or Indiegogo, but the big difference is we have some full process. For example, we have crowdfunding functions and the planning functions and shoppings. So these three playgrounds can provide some full range of services or business plan or business process for IoT devices. Funding is quite important and critical for startups, and there are lots of success stories in Kickstarter and Indiegogo. But unfortunately, their success is only limited to the early adopters, not moving to the mainstream. Certainly, there is a kind of chasm, actually, that was mentioned around the early 90s for the evolution of the internet. Still, we are facing some similar situation on IoT device. So we believe funding is not enough to guarantee the success of IoT device. We need to focus on go-to-market GTM plan as a total. So even in planning stage, we can communicate with the consumers and early adopters to develop right product concept, and we can get the crowdfunding in the site, and in the mass market product marketing, we can get help from pro-style e-commerce platform, and later on in offline distribution, SoftBank networks can help you. Workflows will follow this kind of step. For example, in the marketplace, pro-style is in Japan, and we have partners inside of Japan who can handle all of the logistics to the end users. And outside of Japan, for example, in Korea, SBCK is responsible for the sourcing the IoT vendors and supporting such kind of vendors. So manufacturers in overseas can easily enter Japanese market without a kind of some legal entity in Japan, without any kind of paper company in Japan. So not only for startups, global companies like Sony is participating in this business platform because they have same problems to develop IoT devices market with their own network and power. And Samsung will launch their IoT-related product in this August timeframe. Samsung is #1 fashion company in Korea, and they are designing some IoT belt and fashion accessories in this platform. And more, certainly Taiwanese companies are participating in this platform, and there are lots of partners in Japan and US. We have some unique support programs for the vendors participating in this platform, and actually we can provide kind of some investment, kind of some promotional tools and videos, or we can help their prototyping, connecting some developers and manufacturers. So whole of this kind of support program is quite important because all of startups are always in the shortage of resources. And moreover, we have this kind of alliance to support all of the IT startups in this platform. And the most important thing is to guarantee the success in the offline. That means we finally enter the mainstream, and Yodobashi Camera and such kind of big retailers start to handle this kind of product. Then SoftBank will help you. SoftBank is a #1 IT distributor in Japan, and very close relationship with all of major distributors, stores, so we can utilize that kind of some connections. And also we have very strong B2B sales unit in Japan. SoftBank itself is a kind of media carrier and a media group. We have lots of coverage by ourselves and to promote this website and service. And we can send SMS messages to all of the subscribers to promote your services. And SoftBank has around 2,000 stores, mobile stores in Japan. And another subsidiary, Y Mobile, has around 10,000. And our own stores can be a kind of offline pop-up stores for your new product. Yes, Tech Cafe and lots of other events are held in Japan. You don't need to send your staff who can speak Japanese to participate in this kind of promotion. All of things will be done by our staffs in Japan, and you just send me a samples, then you can participate in this kind of some promotion in Japan. Okay, thank you very much.
Thank you, Vincent, for your excellent presentation. And today's third presenter will be Mr. Howard Wu, Vice President, Head of Product Line Software Defined Infrastructure for Business Unit Cloud and IP at Ericsson. Howard joined Ericsson in 2014, and he has a long-standing career in technology, having rich experience in hardware manufacturing and software services in countries such as China, Canada, US, and Sweden. So ladies and gentlemen, without further ado, I will now turn the program over to Howard.
Good afternoon, ladies and gentlemen. Very happy for all of you to be here and very excited to be invited to this event. Computex is one of the key global events for sure. And on a personal side, you know, my grandparents used to live just down the street, so coming home to Taiwan is always nice. And the topic for my talk today is really around next generation human-machine interaction through IoT. And I apologize for the long title. But I think too often than not, all of us in technology, we always take a look at specific technologies. Is it lower latency? Is it a faster CPU? Does it save battery life? What does it do for me? And we often forget, why are we trying to get here in the first place? So really this next 20-25 minutes, I'm going to present more on a macro view of what is IoT, what are we actually trying to accomplish, and how is it actually going to impact all of our lives? Now, keep in mind, that's just my personal opinion. So take it with a grain of salt. But before we begin, let me quickly introduce Ericsson. Ericsson started in 1876. So this year really marks our 140th year anniversary. It was started by our founder, Lars Magnus Ericsson, together with his wife in their garage. So it sounds like a very similar startup story we see in Silicon Valley these days. Now, 140 years later, what has Ericsson evolved into? Today, our core business is in product side with radio base stations selling into telecom service providers. And we also have a huge global services business that spans our business across 180 countries globally with about 120,000 people in the company. And that puts us in about the top 500 global Fortune 500 range. Revenue-wise, we do about $35 billion a year, and I apologize, this is in Swedish kroner. But a couple of key points that I want to point out, and I think most people probably don't realize. One of them is actually in today's, if you're using a cell phone, let me see how many of you have a cell phone in the room. I'm going to assume it's everybody. And you're probably running through a Ericsson backend infrastructure without realizing it, because we sell to the telecoms directly. And under those, there's about 2.5 billion global subscribers that's running through our backend infrastructure. And of that 2.5 billion, we actually directly manage over 1 billion users. So what does that mean? That means we actually not only provide just the products, but also the services and the fully managed experience for over 1 billion subscribers in the world today. Now, I'd like to dial a little bit back in time to the age of cavemen. And I'm going to use a couple of cavemen analogies, so I apologize in advance if you're offended by cavemen stories. But why did humans create machines to begin with? I think humans, since the days of caveman, we have been using tools. We've been using a lot of tools, mechanical tools, tools to help us hunt better, tools to help us start a fire. And over the years, the number of tools we've expanded certainly helped our lives and everything. And if you really think about why we created tools and why we created machines and why we created computers and everything else, you have to root back to the human brain itself. Now, my brother is a neurosurgeon, so he and I often have discussions, well, neurosurgeon is a fancy word for brain doctor. And we always talk about, you know, from a technology and product side and what he does, what are the overlaps in those things? So if you think about what your brain does, it actually does basically 3 functions. So it allows you to communicate with other people, call it networking. Allows you to retain some memory of things you've learned, we call that data storage. And it allows you to solve problems, we call that compute, right? So actually we created machines to really take over a lot of the functions we see in the human brain. Now, why did we do that? Now, if you think of the brain as a product, and then, of course, you have hardware, and then you have some software. At the kernel layer of our brain, there's 2 fundamental characteristics. Number 1 is the brain is selfish, okay? So the brain will literally cut off blood flow to every other organ before it finally shuts itself down. So that's why when you say you're brain dead, you're really dead, right? And so by that note, we know the brain is selfish. On the other hand, it's selfish, but it's also lazy. It doesn't want to consume too many resources, too much energy. It's looking for the best ROI. It's looking to do more with less. So that also explains our human nature of being both, I guess, selfish and lazy. And that really is what's pushing us to create machines to take over functions that mirrors our brain, so we could do less. And out of that interaction, really, and I guess you've seen other slides by Martin that says, you know, it's going to be 50 billion devices by 2020. I think the future really says it's somewhere between, let's say, 28 and 50. But we know it's a big number, okay? So how do we handle all of these connections? And another thing is, as these machines come online in an IoT context, I think one of the things that we also need to recognize as part of the human race is that also, going back to my caveman analogy, you know, in the days of caveman, we were the major contributor of data on planet Earth. Meaning, if you were a caveman, you were drawing things in your cave of you hunting an animal, you're creating data. We've been driving and doing these data for tens of thousands of years. And now we literally created a new citizen class on planet Earth that didn't exist before. That's called smart devices, connected devices, the coming IoT. So what's going to happen in the next 2 years is we would have created a second-class citizen that actually will generate more data than all of the human race combined in the next 2 years. And even by our estimation, in the next 5 years, if you think about the 13 billion number, that's a human as an end user. The 15 billion devices, that's a machine as an end user. And I'll have a nice architecture slide later, so to satisfy all the engineers in the room. But those are things we really have to think about in a human context, is that how do we deal with these types of connections? And I'm sure everybody has heard about this, seen this, knows about this, but I'll quickly go through it. If we really think about, you know, and I said earlier, in the first, 4,000 or 5,000 years of human, we've been using mechanical things. It really wasn't until the electronics came on board that we started using things we call computers. And if we think about the computing era and the human relationship to compute, you could largely classify into these 3 categories. So the first phase is what I would call the mainframe era. Now, mainframe started, I guess, after World War II. And really at one point, and that was, compute was super expensive. So everybody had to put their money together to buy a big compute unit, we call the mainframe, and everybody had to share those compute resources. Out of that era, a very successful system company emerged, we all know, called IBM. Because IBM at one point, I believe, employed about 80% of American engineers after the war. So it had huge resources, huge efforts into building these big mainframe computers. Then 1980 to 2010, we could say that's the PC era. And Taiwan has certainly played a huge role in pushing that into our daily lives. So really from 80 to 2010, we were getting more intimate with our computers. We were getting more of a one-on-one relationship rather than I have to share my computer with the guy next door relationship. And what does that mean? That means in the 80s, then you remember floppy disks, right? You carry around floppy and carry around data because, well, You know, data was about this big, and compute was expensive. So you carry data around. And then through the 30 years, as we get into cloud, we clearly see now data is huge. Data is massive. The cost of compute went like this. So even our relationship and how we use infrastructure has fundamentally changed. It used to be cheaper to carry data. Now it's cheaper to move compute resources. So how do you manage that in a whole new era? And one thing we did in the PC era was we actually managed to kill all the system companies. So IBM, Sun, all of these traditional system companies, and let's think of system companies the way let's just qualify that term. For me, a system company is a company that does, basically think of ASIC or hardware components all the way to the application layer, right? Full stack delivery solution providers, those type of companies. And because in the PC era, the mantra was do one thing well. Do one thing well and focus on that and make that your core business. So we fundamentally changed everything, and we slice and dice the entire vertical into many different layers, right? And Taiwan certainly plays a key role in that full vertical. Then we come to, let's say 2010. I put a question mark behind 2040 because we don't really know. It's the future. So we're thinking the next 30 years really should be the cloud. And what does the cloud mean? The cloud means we've actually completely reversed our relationship from the mainframe era. Mainframe was super expensive compute, lots of humans trying to take turns using it. Then we went one-on-one with our computer relationship. And now a single sysadmin or anybody who needs to manage a data center, a large-scale data center, can't do it through the internet, right? Through a connection. You now have and that's why we've seen this explosion of startups, and certainly our friends here at Amazon Web Services also can attest to that. We've lowered the barrier significantly to access of technology. You used to have to raise a lot of money just to build infrastructure so you can post a picture of your cat. Now all of that is readily available at a very low cost that actually tracks Moore's Law. So our whole relationship with machines, and in particular with compute, has completely changed into the cloud. So another thing that the human brain does, and that sort of separates us, is that we're able to network to other humans, and we learn. We learn, and we store data. We call it knowledge. And out of that data, we think. And our thinking capability provides us some kind of insight into the future, or we take guesstimates into the future. Important questions, like what am I going to eat for dinner tonight? So one thing we do know out of all of this past historical references is that we know the inevitable is coming. And we know IoT is coming. Everybody in this room knows that it's happening. Otherwise, you wouldn't be here. And what does IoT really mean? It really means at a certain time and point in history, certain technologies emerge and creates a new reality in the way we live and work. I'll reference back to the emergence of the smartphone. And I think if all of you remember about 99 or 2000, we all knew smartphone was coming. A lot of hardware phone vendors were trying to build smartphone-like devices. But then it never happened. It never happened until two other things happened. One thing was 3G happened. When 3G happened, that includes, increase our speed in using our phone devices. Then another thing happened. Apple. Apple figured out the business model. We were all building technologies without a direction and without a clear concept in mind in where's the money. Apple really made application consumption extremely easy. And it changed the way we consume both music and applications. And that changed the entire smartphone industry. That made smartphone come alive. So for the IoT, we have these three technologies coming together. We have a lot of machines getting some memory and a Wi-Fi chip or something. And you guys all, especially in Taiwan, I'm walking around Computex, it's like, yeah, my coffee maker's now online. You saw the other slide from Vincent. My belt is online. I don't know. Does it help me lose some weight? Real-time measurement. So one thing is you have everything you could possibly think of getting connected. The other thing is you'll think about a lot, which is this massive amount of data. Data is everywhere. The fact that all of our cars, average BMW these days has about 80 to 90 sensors. So are you still driving a car that is mechanical, or are you driving a big fancy phone? You decide. The other thing, which is somewhat related to Ericsson, is that we know 5G is coming. And 5G will actually completely change the infrastructure. And I'll talk about that a little bit more. So we know all of these things are coming together in the next 3 to 5 years. And we know all of this is getting put into one big pot. What we don't know is we still don't know the business model. We don't know if it's going to be Apple or somebody else, but we know somebody's going to make a lot of money. We just don't know who it is. But we're all doing our little part in trying to figure out, from Ericsson perspective, we're trying to make 5G happen, right? I'm sure everybody in Taiwan is trying to make connected devices go as fast as possible, and hopefully everybody buys it. And if you talk to any American companies, they're talking about, how do I use software to do analytics and manage data and all of this? So this is really it's a global effort, and we're all working on our specific areas, but we don't know who's going to win. That's the only question. So what are the key challenges? Let's bring it back to the technology level. We know you're going to have massive amount of connections. Pick your favorite number between 28 billion and 50 billion, right? We know there's going to be a lot of diverse use case requirements. I'll use my own household as an example. I'm a regular family. Me and my family, we live in Sweden. So as you heard from Martin, we don't use cash. I can't remember the last time I used cash. And actually, I've had a weird experience where I actually walk into a Swedish bank with Swedish money, and I asked them to deposit it, and they said, no, we don't take cash. So, different world. So in my house, between my 2 kids, my wife, and I, we have 23 connected devices. 23. And I can guarantee you it's a very diverse use case. Between my kids playing Minecraft and me using it for work. And if you even think about your own family as an ecosystem, the different verticals you actually engage every day, right? That's really the problems. That's a miniature of the problem, universal problem we're trying to solve. And then last but not least, everybody wants what? Lower cost, longer battery life, and we want wider coverage. That's like asking for justice, peace, and beauty. Who doesn't want that? So how do we solve some of this? Well, this is the architecture slide for all you architects in the room. You're welcome. This really is the slide for our new world infrastructure. So the key points I want you guys to focus on is the top left. Top left that is a human as an end user. So you think about everything we do to the web today. It's all reading and writing. That's all we're doing. We need a connection so we can read and write onto the web. And how are we engaging that? So everything, the human activity on the web is a mixture of voice media messaging. Everything you could think of. Facebook, Flickr, showing my age, sorry. Instagram, Snapchat. All of that, Twitter, is a mixture of just voice media messaging and the human as an end user. So a human as an end user, what does that mean? That means massive download. That's why we need to go from 1G to 2G to 3G to 4G, because we want everything and we want it now, right? Now on the bottom left, that whole machine-looking icon things, that's the end user as a machine. So what does the end user as a machine look like compared to the end user as a human? The end user as a machine, I can tell you, requires massive uploads. Okay? And another thing that's interesting is, thank God machines are logical. So they use less adjectives than humans, than when we communicate. When you and I talk, I use a lot of adjectives to describe things. Machine languages can be simple, short, asynchronous, event-driven, something like, so even the programming language has to change to maybe something like Node.js, which is, server-side JavaScript, which is asynchronous, event-driven, lightweight types of code. So in this world, the most important thing is control systems. So how do the machines actually communicate to each other? How do they communicate not just through a centrally located data center, but really on the edge? And I think this is, and I said, cloud is really a 30-year journey for all of us. And if you remember correctly, usually the first 10 years of any start of a new architectural journey is starting by standardizing on hardware infrastructure. I mean, we really, in the PC era, until basically x86-1, we couldn't start moving networking onto the web, we couldn't start moving storage, and then also ultimately compute. And when that process was complete, then we move into the cloud. So in that world, a lot of this is machine learning, and how do we do? Of course, being Ericsson, we have a big access thing, right? And of course, I'll explain the rest of the slide very quickly. If you think about our core customers, which are the global telecom service providers, they have data centers and they have central offices, they have, call it regional data centers. None of them call it the same thing, but we know they have a lot of sites. Let's just call it sites. And all of these workloads either go into a public cloud, like Amazon, or they stay certain data into their private data center. And the mixture of using all of this to optimize the cost layer is what we call hybrid. So what does that mean to you and me in real life? I'd like to use an example, and I'll use the connected car as an example. Number one, because I'm a car guy. And number two is my talk, so I get to choose which vertical I want to talk about. And the reason I like to use the connected vehicle cloud actually is really, if you think about me, I'm a human. And me as an end user, I probably generate most data in 3 places. My workplace, my home, probably namely around my kitchen, and then in my car. Okay, so as a human end user, these are the places you actually generate data. Now, I use the car example because today we talk about smart cars, and we talk about smart cities, and we talk about smart cars all the time, actually. But if you really think about today's car, it's not really yet smart for me. Smart car today does what? There's probably a 3G connection, and it probably downloads some maps, and it downloads some apps. So you could consume music when you're driving, and you can know where you're going. But that's not really autonomous yet. A smart car for me has to do 2 other things. Number one, it has to be able to talk to other cars without a human intervention. So how does my car talk to all the other cars driving around Taipei, for example? Another thing the car has to do is it has to be able to make decisions. If it's always a human making a decision, that's not really smart. We think of smart people as the ones who can make decisions for themselves. Isn't that the whole point of education? Is that we can make decisions for ourselves. So when can my car start making decisions for him or herself? And that, what does that require? That, in my mind, really requires pushing compute all the way out to the edge. Why? Because of latency concerns. If I'm stuck on traffic here, and I expect my car to say, okay, I'm going to reroute myself, it can't go back onto a far out data center and then come back. That's not real time enough. It has to sit on the edge. So together with 5G, we make that happen. And that, to me, is more of the smart car evolution. And this is going to completely change. And I think, we're in the era where, like I said earlier, everybody's going to put memory and connectivity into every device you can think of. The next 5 years is going to be a long list of filtering. Because there are going to be things that we just find just doesn't make any sense to make them smart. But then there are going to be things that are extremely useful. So I really see car as one of those home devices that you really want connectivity and you want to do it in a good way. And this is sort of a slide that just talks about the potential business model. Now, we're not saying this is it, But look at the life cycle management of your car. This is the life cycle management of your car. So how do you consume everything as a service? You have to start consuming everything at a life cycle perspective. So really my conclusion is, we are all here, thank you for coming for the talk. We really stand an important time in human history because our machines or our tools never talk to each other. In the next 3 to 5 years, our tools or smart machines and connectivities and devices, things, they're going to start talking to each other. And they're going to start making decisions around what to do, what to read, what to write. And that'll have a profound impact to our human life on planet Earth as we know. And I'm really looking forward to, meeting all of you. If you see me in the corridor, feel free to grab me. Love to say hi if you have some thoughts to share. But I think it's really an exciting time for all of us as a human race. And I really look forward to more engagement with you, all of you here at Computex. And thank you for your time. Again, my name is Howard. Thanks.
Thank you, Howard, for joining us this afternoon. And ladies and gentlemen, we will now take a brief break. We'll break for about 10 minutes. The time now is about 3:15, so the program will resume at 3:25. 我们现在进行中场休息时间，现在的时间大概是3:15，我们休息10分钟，请各位贵宾于3:25再次的回到现场。 Ladies and gentlemen, welcome back to the conference. I hope you had enjoyed your break and the opportunity to network. The next speaker will be Dean Samuels, Solutions Architect Manager, Amazon Web Services. Dean has been with Amazon Web Services for the last 3 years and has worked with businesses of all sizes and industries across Australia, New Zealand, and the wider Asia-Pacific region. He is committed to helping customers design, implement, and optimize their application environment for the public cloud. So without further ado, I will now turn the program over to Dean.
Thank you very much. What an awesome day. Hope everybody's enjoyed day one of Computex. This is actually my first time here. And I've just been overwhelmed with some of the great things that are happening here. And I'm actually so excited to be able to be here to talk to you around one of the really hot topics in the industry today. Other than maybe big data and analytics in my industry anyway, Internet of Things is basically something that I'm constantly talking about every single day with our customers. As customers see ways that they can develop new business models, they can develop new commercial processes. They can leverage technology to really innovate and, as was mentioned earlier, disrupt the industries they operate in. Just to give you a bit of background about Amazon Web Services. So many of you may have heard of Amazon. Okay, so Amazon, Amazon.com, the online retailer, is actually made up of many businesses, not just online retail. So Amazon Web Services is actually a 10-year-old business unit of Amazon. And what we provide is cloud computing services. Okay, what does that mean, cloud computing services? It's basically a way that we deliver IT services, whether it's the foundation of compute, storage, networking, all the way through to managed services, so things like machine learning, like analytics, like IoT backends, like big data, like desktop productivity, but delivering these IT services in the same way that you actually consume utilities. Utilities like water, utilities like electricity. So if you think about when you consume those utilities, you turn a tap on, you start consuming the resource, and then you turn the tap off. So the way that cloud vendors like Amazon Web Services deliver IT services is very similar. You want to leverage compute, you power something on through a call, you use it for a period of time, and you power it off. If you want to leverage something like a data warehousing platform, you turn it on, you analyze your data, and you turn it off. The main advantage of that is not actually cost. Yes, cost is a benefit of cloud computing, but it's not the number one reason why we're seeing a lot of organizations, big and small, moving to cloud computing space, to the public cloud. The number one reason is around agility, the ability to be disruptive in their industry, the ability to innovate very quickly. And so when we start talking about IoT and the ecosystem around IoT, this is where organizations which didn't exist a year ago are actually taking advantage of cloud computing, where they can build those IoT ecosystems. Okay, so that's a little bit about Amazon Web Services. What I'm going to focus on today is really how Amazon, so our parent company, how Amazon has developed various IoT ecosystems to make it a lot more efficient and to improve the customer experience when accessing the Amazon.com e-commerce platform, making it available to all of our customers around the globe in a very efficient manner. But most importantly, how we've taken a lot of that technology and a lot of that learnings, and we make it actually available to the wider industry. So other organizations can take our learnings, take our technology, and leverage it in their own businesses, whether they're a similar e-commerce provider, whether they're working in a different industry altogether. They can actually take these learnings and apply it themselves today. So we've spoken a little bit about being connected. Okay, why do we want to be connected? Okay, being connected and connecting everyday things really gives us a lot more insight into the world we live in. When we talk about being connected, We're talking about taking a lot of data, analyzing that data, predicting what might happen in the future, making our lives easier through automation. And one of the most important things about the Internet of Things, you'll notice that things is actually plural. The real benefit of Internet of Things is the ability for different everyday devices and things to communicate with each other. So there doesn't actually have to be a human being involved in that entire process. And this is when you start to get those insights and that automation by living in that connected world. I find it quite fascinating that today I could buy a full computer for under $5. It's amazing, $5 for a full computer. It's got memory, it's got a CPU, it's got some storage, it's got some network connectivity. Okay, yeah, Intel Edison or a Raspberry Pi, it's an actual computer, but you can purchase it for under $5. And what we're starting to see, and it's been mentioned actually a few times, I'm in the boat of agreeing that by 2020 it's going to be 50 billion devices, all connected. Because if you think about it, everyone in this room has probably got more than one device that has internet connectivity. You've got your mobile phone, you've got your tablet, you've got your computer, you've got a smartwatch, you might have other sensor technology. So if you think about that 50 billion number, and take into account population growth up to 2020, that's about 5 or 6 devices for every single man, woman, and child on this earth in 2020. According to a McKinsey study, by 2035, we'll have 1 trillion devices that will be connected. As the cost of devices goes down, as the cost of network connectivity goes down, as technology evolves, we'll see an explosion of these devices in a connected world. So how did it all start? How did it all start? Internet of Things, or the ability to connect everyday devices to the internet, is actually not a new thing. It actually happened way back in 1989. So over 30 years ago. Or sorry, just under 30 years ago. So what basically happened is one of the founders of an internet event, an annual internet event, quite a large one at the time, it still exists, called Interop was the event. And so one of the founders actually challenged John Romkey, highly respected engineer, to come up with an everyday device that would have internet connectivity that could be controlled over the internet. And so in 1990, what happened at the next event, he actually came through. And he delivered the internet toaster. It was very rudimentary, very primitive at the time. Okay, it was very over-engineered, as you could expect. But it had the ability to basically toast bread. So over the internet, through just turning the toaster on and off, you could actually toast and control the amount of time that that toaster would work. And how far we've come now since then, where companies are starting to identify the true value of connected devices. And so when we talk about Internet of Things, so there was a slide up in one of the earlier presentations about Internet of Things is just not the connectivity. Okay, connectivity is the easy part, technology is the easy part. We've got things that exist today around home automation, we've got things in various industries around robotics, we've got things in agriculture using sensors that are connected. That is actually the easy part. There's many manufacturers in that field, allowing that connectivity between those devices. But where you start to see the true value is when you develop that actual ecosystem around it. Working with partners is key to doing this, because creating an ecosystem can be very difficult, and I'll go into that in a moment. And so products are going to get smarter over time. Okay, I mentioned about that $5 computer with your Raspberry Pi. Okay, and these devices are going to get cheaper, they're going to get smarter, they're going to collect a lot more data, they're going to be able to perform a lot more things. And I mentioned about collecting information. The idea is data is going to be king. He who owns the data is going to be king. And it's what you do with that data that's going to be most important. And if you think about what you can do with that data, there's really 3 things. You collect the data, you have no idea how you're going to utilize that data. You have no idea how you're going to monetize that data. You have no idea what type of insights you'd like from that data. And so what you're actually doing is you're capturing that data for later use. So you're archiving it for historical purposes, and maybe later on down the track where you can identify ways that you can innovate on analyzing that data, you've got that data available for you. And so that's how we analyze historical data. The second way we access and analyze that data is in real time. Okay, real-time dashboards, for example, giving us real-time insights into what is happening in the world around us. And so many organizations provide the ability to show you these dashboards. What's the temperature in your house? Okay, it's reached this temperature, I'm going to turn on the thermostat. Okay, I'm approaching my house, I'm going to turn the lights on. Okay, in agriculture, I've got sensors in the soil. When there's a limited moisture, I'm going to turn on the irrigation system. So that's stuff that exists today. Where we're going to see the true value is that third way of analyzing data, predictability. So taking that historical data and making predictions from that historical data, identifying patterns in that data. And that's where things like machine learning comes into play. And that's an area where we're actually seeing a large uplift or uptake with our customers today. And I mentioned that this occurs across all industries. So Amazon Web Services works with, like I mentioned, agricultural companies. We work with things like irrigation systems, so optimizing the way that they're using water. So being conscious of the environment around us, using that water in a way that is very efficient and reducing that footprint on the environment. And so using things like sensor technology in the soil, using sensor technology in wind farms, using sensor technology in solar plants, and basically reacting to certain events that occur in the world around us. We work with companies in retail. We happen to be under the Amazon brand. Amazon.com is a customer of Amazon Web Services. And I'll actually show you how Amazon.com is innovating in our fulfillment centers, being able to deliver on orders in a very short amount of time, up to 1 hour when the order is placed by the consumer, and how we can do that in our fulfillment centers. Now, this is all well and good. Okay, we've been talking a lot about how Internet of Things is the next big thing, but it is actually very hard and can be very hard. Devices themselves are very hard to connect, and they're very hard to manage. There's certain things you've got to take into account. Do you imagine if these devices exist in a very remote or regional area? Internet connectivity isn't going to be that great. It's not going to be that stable. It's not going to be that fast. So we need ways of how to adapt and how to manage that type of environment. You could have environments which are quite extreme, very hot, very cold. Okay, how do we have those devices that require minimal management in that minimal maintenance in that very remote area? Things also don't interoperate out of the box. We wish they did, but we have many other vendors or manufacturers. We have many other organizations. So we need a way to glue those solutions and glue those ecosystems together. So that's another challenge we face. Another one is around signal to noise. And what we mean by this is we're collecting vast amounts of data. How do we know what data to actually push up into the cloud or up into your backend? And this is a challenge as well. We want to minimize the amount of data that's been taken from a lot of those things or those sensors in the everyday world. So how do we decide how to do that? And also, applications and things don't always match. Okay, you have different vendors, you have different organizations, you have different applications. How do you actually interconnect those? So these are some challenges we face, and I'll talk about how we've addressed those challenges. Before I get into that, I just want to talk a little bit about what we see at Amazon as the 4 tenets of IoT solutions. What makes a successful IoT ecosystem or IoT solutions? So number 1, I mentioned before, agility. In order for organizations to be disruptive, in order for organizations to innovate, they have to be very agile. The time to market that they bring their ideas has to be very quick, otherwise they're going to be disrupted. And so the platform and the ecosystem that's used needs to be the ability to be very agile. And that's why a lot of organizations that are looking at IoT as a business are leveraging things like the cloud platform or public cloud platform. The ability to spin up those services very quickly and utilize those services. It needs to scale. Who knows, maybe your idea takes off, becomes viral. You need to have a platform, an IoT ecosystem that can scale for demand. And when we talk about scale, we're not just talking about scaling up. Because at periods of time, the environment might have lesser demand based on your users, based on the time of day, based on other variables. So we need a platform that has that ability to scale down and scale up based on actual demand. Once again, why public cloud is generally the platform of choice. Security should actually be listed first here. Security should be the number one priority. You're sharing a lot of information, you're transporting a lot of information. And a lot of times that information needs to be highly secure. So you need a platform that has that end-to-end security in place. So things like encryption for the data that's being transferred and the data at rest. Things like control over that logical access of the data. Okay, things like access control over the location for that data. And of course, cost. You want to ensure that you understand and can control those costs and be able to pay the minimal amount for that actual platform. And so I just wanted to quickly map to technology. There's certain requirements in an IoT ecosystem. Okay, what are the various components that might make up an IoT ecosystem and how it actually maps to the AWS services? Okay, so if you think about devices talking to other devices, there's various stages that we go through in that architecture or in that ecosystem. Okay, from the ingestion of the data. So millions, if not billions of devices pushing information to a location. You need a component or a facility that is highly scalable and can support the ingestion of that large amounts of data. You want to analyze that data. You want to build a rules engine. What are you going to do with that data? Are you going to simply archive it for later use? Are you going to analyze it in real time to provide those dashboards? Are you going to feed it into some type of machine learning system for predictions? And then you want to also look at providing that data or providing that results to your users or to your consumers or to other businesses, depending on what your model is, B2B, B2C. Okay, so how do you present that data that's been analyzed to those users? So there is a full range of technology. It's not just simply one technology that's required for your entire IoT ecosystem. And I mentioned about partners. Partners is going to be very key to us. So we work with quite a number of partners. So for example, locally here in Taiwan, MediaTek is a very good partner of ours. A lot of their development boards and sensors actually have embedded technology that integrates very easily with the AWS platform. We've worked with Intel, for example, and I'll talk a little bit about Intel on the next slide. Intel is bringing out devices that has native integration with cloud platforms. And so the ability to collect and aggregate information at the edge, and the edge was spoken about a few times earlier, collect that information at the end, filter it down, and only send what is actually required into the cloud. But it's more than just the technology and the hardware. It's also things like those strategic partners and things like the analytics partners, because once we have that data, we need to decide what are we going to do with that data. And so I mentioned about Intel. Okay, so this is the Intel IoT Gateway. And gateways actually have been around for quite some time. It's not a new thing. Okay, but we worked with Intel to embed technology onto the actual device so that these devices can actually remain at the edge. So it improves that last mile. So those devices which are maybe in areas which don't have much network connectivity or stable network connectivity, areas where the bandwidth is quite low, devices such as these gateways provides that ability to collect that information, filter it, and then send it up into the cloud for your preferred analysis. And so we're working with Intel as well as other vendors to support this type of technology across different industries as well. So what I want to show next is just a quick video of how things work in the Amazon fulfillment centers. Okay, so these are the locations where orders come in from our consumers, and those orders get fulfilled. It's a big warehouse, so you can imagine these very large warehouses. The biggest ones are about the size of 30 football fields. So a very, very big building. And so we found that having human beings walking around that fulfillment center to fulfill orders, to grab items from the racks, wasn't very efficient because we wanted to introduce things like same-day delivery, or even, in some cases, within 1 hour delivery. And so having human beings running around the fulfillment centers in order to retrieve those items that are ordered would not be able to fulfill that service. Okay, we wouldn't be able to achieve that delivery model or delivery time. And so what Amazon actually did is we acquired a company that provided what we call these Kiva robots. And there's actually a new company that's born out of that called Amazon Robotics. And so being able to export that technology and export our learnings to other organizations as well. And this is what it looks like. Okay, so one of our fulfillment centers in North America, these are the Kiva robots. And the reason I wanted to bring this up is because these are internet-connected things. They're actually talking to each other, they're talking to backends, they're talking to different devices, they're talking to different applications, all internet-connected. And what they're doing is they're, as you can see, running around the fulfillment center. They've got various sensors themselves to make sure they don't bump into each other. Yeah, but by running around these fulfillment centers, actually grabbing the racks that the items that have been ordered exist in or are located in, and they actually bring it to the front of the fulfillment center. And there's human beings which will then take those items, package them up, and send them out. And so by doing this, we have multiple efficiencies. Number one, storage efficiency. You can imagine that we are able to place more racks within a fulfillment center because we don't have to allocate space for human beings to walk up and down the aisles. Number two, we improve the efficiencies around retrieval of the racks. So we can achieve that same-day delivery. We can achieve that within 1 hour delivery of certain items. And this will integrate well when we start looking at delivery through drones. So that's another area that we're looking at, and also around Internet of Things. Having these automated drones delivering certain packages to certain users in certain areas. Okay, so always changing and always innovating on the entire customer experience. The next video I wanted to talk through is around a product that some of you might know. It's called the Amazon Dash. Okay, so Amazon Dash, I think I've got an example here. So this is an Amazon Dash. Okay, you might be thinking, looks like a button, it's very simple, what does it do? So the Amazon Dash is something that we brought out for consumable goods. So things like items in your kitchen, food. Items in your bathroom, toothpaste, soap, shampoo. Items in your laundry, dishwashing detergent. Items for your pets, pet food. And what will actually happen is these dash buttons map to a single item, a specific item. So let's say, for example, washing detergent. So you can stick these buttons near your dishwasher or near your laundry. And so anytime you run out or you run low, all you need to do is push the button. And that will automatically order that item from Amazon. So if it falls under the same-day delivery category, that day you'll have it delivered at your door. Or more than likely, within the next 24 hours or 48 hours, you'll have that delivered to your door. Okay, so let's have a look at the video. So basically what happens is each one of those items, there's about 500 items right now in the catalog, has one of these. That's been me a few times in the morning.
Introducing the Amazon Dash button for Prime members, a simple way to reorder the important things you always run low on, so you'll never run out. Set it up to order what you want, then press it when you're running low. Get an order alert on your phone, so it's easy to cancel if you change your mind. And with Prime shipping, you'll get new products delivered to your door before you run out, and never miss a beat. Prime members, request your Amazon Dash button today.
Now you're probably thinking, well, that's great for Amazon. What about me? So what Amazon's actually done is we've taken this technology and we made available the AWS IoT button. This is actually an AWS IoT button. What does that mean? It actually means you can program into this device anything you'd like. It doesn't have to be ordering from Amazon.com. I could program into this device so that when I press it, it orders me an Uber. Okay, that's actually what I've got now, so actually I hope it's not working, because otherwise an Uber's going to come to my house in Hong Kong. So pressing the button, it's locked in, it's got the coordinates for my house in Hong Kong. Press the button, I walk down, as soon as I come out of the lobby, my Uber should already be there. I could program this into my home automation system, so the existing home automation systems that you have. Okay, maybe something like SmartThings or D-Link or home automation. And so when I press the button, maybe it's at work. Press the button, and it's going to turn on certain things within my home. It's going to turn the air conditioning on to my preferred temperature. It's going to turn on certain lights. Maybe going to start up an appliance like a coffee machine. So that when I get home, all of those different components are there ready for me straight away. I could order a pizza. So Domino's has an API, so I can program this against Domino's. So my favorite pizza, anytime I press the button, that's going to be delivered to my door. So it's just a very different way that we can interact with various services, and it doesn't have to be Amazon. One of the great things I like about the Dash is now being extended into appliances. You don't need to purchase this actual device. So we're working with a lot of appliance manufacturers to incorporate a button either onto the appliance or a sensor onto the appliance. So that when that appliance, let's say it's a coffee machine, is running short of low of capsules, it will automatically place the order for you. Just wanted to also talk about the Amazon Echo, another way we can interface with the world around us. That's an example of the Amazon Echo on the podium over to my left.
Alexa, how many championships has Dan Marino won?
Dan Marino has won 0 championships.
Alexa, how many Oscars has Alec Baldwin won?
Alec Baldwin has won 0
Alexa,
Oscars.
stop. Well, time for me. Shame on you! This man is a national treasure. Jason, it's over.
No, it's not over. I will set this man so hard for you.
No, you won't. Gentlemen, we have over 100 million people watching us right now.
100 million people? Hey, Alexa, release that new song, Pet Rally by Missy Elliott. Hey!
Yeah.
Okay.
He's okay, he made it.
Jason, what do you think? We were very bad boys.
Alexa, what's in the news?
Here's the news.
Alec Baldwin and Jason Schwartzman were seen mooning paparazzi. Baldwin threw his shoe at photographers before making a run for it.
Poor Kashmir socks.
Alexa, reorder another pair of Brescianis.
Reordering Bresciani socks.
Okay, listen, can you send some lawyers or something?
So again, I wanted to bring that up because we brought out what we call the Amazon Voice Service. So it actually allows manufacturers to leverage the technology in any device that has a microphone and a speaker. So it doesn't actually have to be this device on my left here. So manufacturers can use that Amazon Voice Services technology in their actual device to communicate with the cloud. So in this case, with Amazon Web Services, because we have another piece of technology available called the Amazon Skills Kit. And the Amazon Skills Kit is what interfaces with all the different services on the AWS platform. So it really encourages creative thinking and innovation with our customers and partners as well. I'm out of time, so I might have to skip this last video. It was just actually introducing one of our customers leveraging the AWS platform. But Ratio used one of our new services, the AWS IoT service. And essentially, it just means that customers don't have to worry about building IoT backend infrastructure. They can actually plug directly into this managed service, so they can focus on their actual IoT service model rather than actual backend. But Ratio, it's basically a home automation sprinkler system. So it's a set of sensors that you actually have around your house, measuring moisture, measuring temperature, measuring light, that will actually automatically turn on your sprinkler system based on certain events and certain things that happen in that environment. So with that, thank you very much for your time. Hopefully that's been a little bit insightful. Hope you've identified or gathered information around how you can leverage a lot of our learnings in terms of technology as well as processes to actually build your own IoT ecosystems. Thank you very much.
Thank you, Dean, for joining us this afternoon. And the next speaker will be Zach Shelby, a Thread Group evangelist and the Vice President of Marketing for Internet of Things at ARM. Zach has a long history of thought leadership in technology and standards for IoT, and he has co-founded a successful startup and published a book on Internet Protocol over wireless personal area networks. So ladies and gentlemen, without further ado, please welcome Zach Shelby on stage.
Thank you very much, and hi again, everyone. So some of you saw me here this morning talking about developers and IoT and innovation. And now I want to talk to you about something that's really close to my heart, and that's networking for the Internet of Things. How do we connect all these great devices to what, in my opinion, is the real definition of the Internet of Things? Hook the devices up to the Internet. We get the devices onto the Internet, we can communicate with them over any infrastructure, right? With any cloud service, with anything you want. That's the beauty of the Internet, right? IP packets go where we tell them to go. They don't ask questions. And I'm going to talk about a new standard that we helped to create at ARM, and with many other players that we collaborate really closely with, including Google Nest, which is the first adopter of this technology in Nest products, including the thermostat. So before I go deeper into Thread, raise of hands. How many of you have heard about Thread? Okay, okay, we have some. How many have heard about Wi-Fi? All right, okay. So Thread, think of Thread as the invisible Wi-Fi for all the smart devices in your home that you never have to think about. You don't have to try very hard to set it up. It just works. You don't have to install more access points to get coverage because it's mesh. This is Thread. So Thread's really exciting. This is a new technology that's really revolutionizing how easy it's going to be to connect really low power, cheap home devices to the Internet. I'll talk more about that. Now, my history with this technology goes back a long time, which is why I'm really proud to be talking and have been involved with the standard. I actually started working on IPv6 standards for the Internet of Things back in 2001. We wrote the first standards for this back then. We went to the Internet community and told them about all this great work we did, and they basically told us to go home. They said, no, we don't need any of that. IPv6 rules, Internet will get faster and faster, Ethernet and 100 gigabit per second over the air. Some of you remember those days of networking, unlimited bandwidth, right? Well, it turns out that wireless doesn't follow Moore's law. You don't get more bandwidth and less power and more range, right? You have to trade off somewhere, and it turns out you need to trade off a lot if you want really low power and really cheap. So we didn't end up with hundreds of gigabits per second for everything in your home. We need to make compromises. Now, as the years went on, we actually successfully made this technology part of the Internet, and it was something called 6LoWPAN. Now, many of you have surely heard about 6LoWPAN. It's the small IPv6 networking for lots of different systems. I'll tell you about some of the other ones a little bit later. And that made its way into standards in 2006. I founded a company that did some of the first stacks for 6LoWPAN, which eventually became this technology, Thread. So I've been involved a long time in making this happen. Now, I'll talk a little bit about Asia. Don't worry, I'm not going to talk a lot about market numbers. I know everyone's heard more market numbers than they ever wanted, but a little insight into what's happening in smart home in Asia, because I think that's really important for all of us here. Now, Asia is really being seen as the front line of IoT. I mean, this is coming from Western market analysis companies like IDC. We're really seeing the pickup in Asia for smart home. It's incredible. It's even bigger than in the West. And in particular, one thing that is really standing out to me is that, among everything else, is that 1 out of every 5 connected devices in the world will be in China by 2020. 1 out of every 5, and this is not 1 out of every 5 in Asia Pacific. This is 1 out of every 5 devices on the entire planet will be in China. That's an incredible number, and this isn't just smart home, this is everything. So let's talk a little bit more about smart home. So smart home's becoming an interesting market. It's growing. There's real business today. It's actually growing at a healthy rate continuously. The issue with smart home, and I think the biggest issue, is it's fragmented. We have a lot of fragmentation in the home. We have a lot of competing standards. We've had a lot of proprietary technologies that don't actually connect to the internet. Some people don't know this, but things like Z-Wave and Zigbee don't actually communicate to the internet. It's a local technology. You need a gateway. It doesn't really scale in the long term, in my opinion. So we've done some work to actually go create a standard that we think scales for Internet of Things and complements things like Wi-Fi. So by standardizing on some of these things, bringing everybody in the industry together, we're going to defragment the market. That'll allow us to grow. It'll allow us to make consumers a lot happier because the technology just works. Now, I talked about China being a lot of the market. If you saw the number earlier, it was 30-some billion. Exact number doesn't matter because it's not right. Look at the China smart home market, 22.8 billion. It's a big, big chunk of the total market in the world. So there's more market in China around smart home than anywhere else in the world. And consumers are actually really open to this. If you talk to consumers in the West, in the US, for example, ask them about smart home, they'll be like, yeah, I'm not so sure I want more smart home in my house. Is somebody watching me? And how can I trust? And who's going to charge me? And they're suspicious, right? But actually in China, we're seeing responses from consumers like 55% saying, yes, I'm very interested to have more smart home. They're interested in the technology, they want it to work, they find it fun. And there's some real use cases driving this. So for example, pollution and smog, air problems in mainland China in particular. Real problem. People are worried about their kids, they're worried about themselves. And the smart air purifiers and air conditioners are really driving that smart home market. It's the kind of inroads in China. In the US, it's different. It was the thermostat. Finally, somebody managed to make an easy-to-use, useful smart home device, and that was Nest. So Nest actually recreated the thermostat and made it more useful for people. They solved a very simple problem, and they made it useful. And that was the inroads in the US market for the smart home. So different type of problem that's being solved, it's air purifiers and air conditioners versus thermostats. Now, why do we need a new wireless standard? So we have Wi-Fi, we have 5G, obviously. We'll talk a little bit about that more with Howard. Not sure I completely agree that 5G is going to be the thing for everything. Why do we need another one? And there's a few reasons. We went and looked at what do we really need for a home automation network to work well. It needs to be low power. It needs to be resilient. Like I talked before about the internet protocol, we really need to hook it up to the internet. We want open standards. We don't want something that's very proprietary. We need it to be secure. It's got to be pretty fast to bring products to market. And of course, we need existing radio silicon. We can't wait for several years while we go design new radios and get a new standard to market. So it's got to be software, right? No new hardware. And we couldn't find anything that really fit this, right? This is the magic we've been looking for many, many years, and nothing like this exactly has existed. So we had to go create something. Back about 3 years ago, I got a phone call about a week after I joined ARM. So my company was acquired by ARM, joined the company, oh, this is great. And several people call me, oh, there's this thing happening, Thread, Nest has got this great thermostat, and we're going to bring all this stuff to market. I said, wow, that sounds exciting. So I got involved with helping to set up this thing called the Thread Group. And this was 8 companies. ARM was involved with some of our silicon partners, some consumer product companies, and of course, Google Nest was leading the effort because they had a real product that needed the technology. We finally launched in 2014, and something incredible happened. I've never seen this happen with any organization. And organizations really are about ecosystem. It's not any one company that drives it. We do it, so together we have a strong standard. We already have over 230 companies that have joined the Thread group and are committed to bringing real smart home products to market, infrastructure, gateways, operators who are going to run the networks in the home. And I think that's incredible. In just a short 2 years, going from 8 to 230. Very cool. So there's a lot of interest in smart home around standards. It's nothing like I've ever seen before. Now, something special about Thread, and this is really the thing that makes it different than other standards. I'll go into the technical details about what's different in Wi-Fi, what's different with cellular, what's different with Bluetooth. But the real big difference is that Thread does mesh. And I know some of you that are networking engineers go, ooh, mesh. We know how difficult that is. Mesh is hard. But if you get mesh right, it has a lot of cool things about it. So it eliminates your single point of failure. It's a little bit of an issue with Wi-Fi. It gives us some self-healing capabilities. It's self-extending. So if you put that one smart home device just a little bit further away, you don't have to start installing more access points, trying to configure and debug why. It will just work. As long as you have a few devices around the home, it will work. And that's really important. This ease of use, the customer experience when you put this product in your home for the first time is the most important thing. It's got to work the first time. It's got to be easy. Now, our vision for the world in general at ARM and in the Thread group as well is that we're really seeing IPv6 evolve into the super connector for the Internet of Things. All these different networking technologies, what they're doing in the end is moving data to the edge of the Internet. Once it hits there, boom, you're in the pipe. The packet will go to AWS where they want it to go in the right data center. It'll get load balanced, and we'll do all the magic that we know how to do. Ericsson and 5G will take care of all those packets and get them to the right place securely. We know how to do our job as network engineers, but we've got to get all that data onto the Internet in the first place. And all these technologies do that in their own way. And I'd claim that we need all of them. We're not going to get away with one winning wireless technology. We're going to have 4, 5 that do different things for different industries. Wi-Fi, of course, is super important. Wi-Fi is the kind of backbone of local wireless computing. I live on it at home. I live on it at the office. I can't survive without Wi-Fi. And Wi-Fi will continue to be really good for a lot of Internet of Things applications. So we find Wi-Fi to be critical. And what Wi-Fi really is, it's 802.11, the standard from the IEEE, with IP networking on top, V4 or V6. Bluetooth Low Energy similarly is very important, right? We wouldn't survive without all of our Bluetooth Low Energy connected gadgets. And that's great when you have one of these. But Bluetooth Low Energy has really been concentrated on the phone market. Something that not all of you might be familiar with is that we recently standardized the use of IPv6 over Bluetooth Low Energy. The new development in the industry. We did that between the IETF and the Bluetooth SIG. And what it means is that we'll actually be able to start sending IP packets in the near future. We can already do it with specialized home gateways that allows us to have a Bluetooth Low Energy tag, for example, a beacon or a simple accessory sensor, work not only with your phone, but with your home gateway, and send packets transparently to the same service as you. So we could do, for example, a Bluetooth Low Energy enabled dash button. And thank you, by the way, Dean, for bringing up the dash. That was my example this morning with the coffee maker. We thought that was great. It just kind of proved to us that the industry was going where we thought it was, which was connect devices up to consumer experience and make that whole ordering process easier. And that's really happening, which is cool. So we could use Bluetooth Low Energy for that. We could use Wi-Fi for that. We could even use cellular if it's a high enough value product that it makes sense. But for a lot of home applications, what we need is low power, we need easy, we need fully distributed within the home. And that's where Thread's going to make a difference in the market. And we think it's nicely complementary to Wi-Fi. In fact, what we're seeing is that Thread is extending Wi-Fi in the home. It's not a replacement for it. We're actually using Wi-Fi to get to the first hop, and then we're using Thread to go further. I'll show you the architecture of that. Now, on top of all this, remember how the internet works, it's layered. We believe in really strong layering. So on top of IP, you're going to use several different application protocols, and they're going to go to several different types of applications. So there isn't any one application layer for Thread or any other IoT technology. So what this gives us in the end is an easy to install system. I'll talk about security. I think the security model is super important. If anybody who's tried to install Wi-Fi equipment and make that securely commissioned, it's a bit of a mess. A lot of proprietary ways to solve the problem. There's no real standard way to do it. And we can handle up to 250 devices per network. So way beyond what we can do with Bluetooth Low Energy. Not sure what Wi-Fi does when you start putting 200 Wi-Fi devices in your living room. Could get interesting. I've never tried that myself. And as I mentioned, we can run many different types of application protocols. And I think this is super important because applications evolve quickly. This is where the innovation happens. We need to let manufacturers get their job done in the home. So everything from Nest Weave, which is how Nest connects their products and their ecosystem together, to the IoTivity standard from One Alliance to Zigbee, which actually is transforming into an application semantic standard over IP networks. That's a new iteration of the Zigbee standard. It's actually pushing application semantics onto the internet rather than onto the old Zigbee protocol. That's a new thing. Now, all these things can be run over these networks, including good old HTTP. It's just do the HTTP that you want to do. So this application layer agnostic is super important. Now, what kind of applications are we looking at? Well, just about anything in the home. Anything from appliances, access control with locks. We've seen products already come out. The air conditioning and air purifiers we looked at for the China market, to lighting. And in the future, as a standard like this becomes more popular, devices are inexpensive, high volume, you'll see it go to other applications. So even though the target market is smart home, you will see this be used in smart buildings, any kind of application where 2.4 gigahertz is suitable, and the types of ranges we're talking about are suitable. You don't have too many nodes. This doesn't deal with 5,000 nodes on a single access point. It's up to 250 approximately. So it has to be the right kind of application. So Thread will expand to more things. Now, how do we actually build a mesh in the home? And this is interesting because what we've seen happen through the Nest thermostat as a good example of a product is that we actually run Wi-Fi to the thermostat as the first hop in the home, as I mentioned earlier. So Wi-Fi acts as the first hop. We can have more than one what we call border routers. So this is the thing that routes from the low-power devices onto the high-power device, or high-power internet, so Wi-Fi or Ethernet or cellular. So the Nest thermostat acts as a border router. We can have a larger number of routers. Routers actually relay packets. Routers are typically powered devices. It might be a wall socket, it might be a light. We typically want to use the powered device to route because it eats up more energy. Battery-powered routers are possible, but they need to be a little bit bigger on the battery. And finally, the end device. Important thing about the end device in a mesh network is it's got to be low power. The end device doesn't route for others. It's very silent. It just waits until it needs to do something. And we can even deal with sleepy nodes with routers, and I'll explain how that works in a moment. So all in all, what we end up with is a network where we can build up from several border routers to many thread routers to many end devices per thread router, and that gets us hundreds of devices in the end in one home network. Now, what if we have multiple homes, multiple apartments? That's okay. We have multiple channels to work with in 802.15.4, and that means we can assign channels automatically in denser areas to avoid collisions. So your home will be in a different channel than your neighbor's home. At some point, we'll have a density issue. We'll have to deal with that. For example, more spectrum, different fields. We have the same problem with Wi-Fi. So we don't get around the 2.4 gigahertz collision problems completely with this. That's something we'll have to deal with. Now, security. Or I'd say not just security, it's the user experience of bringing a new device into your home. Security alone is that's the term that us engineers use to what we're doing. But as a consumer, you don't think about security. You think about, well, I bought this thermostat, and then I bought this Nest smoke detector that's going to go on my ceiling. I want to bring it into my home, and it's got to work, right? And the way that we do that in Thread is really interesting. We've done it and designed the entire system to be a consumer model for commissioning a device. We literally avoid all the passwords, all the SSID, WPA keys. There's no keys that you enter in the device. You do something very simple. You take an app like this, and there's a little QR code that comes on the product. And you simply take a picture of that QR code with your phone. And then it goes back through your IP network in your home, doesn't talk directly, through the IP network in your home, it will go and make a secure tunnel to the device. We use technologies like DTLS and JPEG cryptography to make that happen in a secure way. And it then tells the device that, hey, yes, you're allowed onto my network. I give you the rights to be on my network. And boom, your device is now talking to the internet. It's not talking to some proprietary gateway. There's no special application that needs to be there. It's actually talking to the internet. We could go and send data to any service that we want to. And that's an important thing. That makes commissioning devices in the home a lot easier than anything we have today. Easier than Bluetooth Low Energy, easier than Wi-Fi. And something that's really important for me is that we can even export that function to the cloud. So think about an operator. In the US, we have Comcast, provides a lot of the home automation systems that are out there and in deployment. And if you know the codes of the devices that you've actually shipped to the customer, I know Amazon knows that, you can automatically pre-commission those devices through the cloud with that tunnel so that when you bring that product home and turn it on, it can automatically get onto your home network. Boom. Now there's no QR code, there's no picture taking, it just works. So operator-assisted commissioning is even cooler. That's the one I'm really excited about because then we can know how these devices are supposed to be. So exciting times in commissioning in the home. This is something that's going to make our lives a lot easier. Now, something else that's important is that in a lot of these systems, low power devices is kind of it's a little bit of a trick. I think here we've done a pretty good job of making low power sleeping devices really work. And a sleeping device means that your end device actually turns off for periods of time. It's not on listening all the time on the network. We have this issue with Wi-Fi. It really turns off. And what it lets us do is poll parents in the network and store packets for forwarding to that node when it wakes up again. So nodes can safely go to sleep for longer periods of time. We save power. They come up and just check if there's anything on the network and go back to sleep. Very simple type of technology. Now, something that was critical in both Bluetooth and Wi-Fi for their success was certification. And the same thing is happening with Thread. It's actually in progress right now as we speak. Certification for the Thread 1.1 spec is ongoing, and we hope to finish that as full certification by sometime later this summer. And that will mean that we'll get the first full Thread certified devices on the market. That's not stopping smart home manufacturers right now. Pre-certified products are already in the market. We have fans, we have locks, we have all kinds of products from Nest, shipping in high volumes. But we're waiting for the final certification. We think this will be important for the industry to know that, yes, this will work with other products, et cetera. And we've done a lot of work to make sure that the technology is available for everyone. So there are actually multiple implementations of the Thread standard. Our team at ARM has done one of them. It's part of the Embed project. You can actually download that for free at embed.com. And you can get a hold of Thread today on multiple silicon platforms with multiple radios. NXP and Silicon Labs have both done their own implementations on their hardware. And just recently, about 2 weeks ago, we had an announcement from Google that they've created an open source project called OpenThread. And OpenThread will be available now for download as well. It's not complete, but it's a good start for an Apache-based open project you can download and use in a product. So we're seeing some good movement on implementations of this that you can easily get a hold of for 15.4 hardware. And of course, like we've heard a lot in the conference, startups are important. Startups are important for me personally. They're important for a lot of us companies because we know that's where innovation's coming. And they're important for Thread. So in order to help seed innovation in this space, we're actually giving away memberships for startups. So startups that go tell us about their interests, we have an enabler program they can come and apply for this, and once a quarter, we give away a membership to a startup. And that allows them to get started, kind of get kick-started into this ecosystem and design products without having to hit their budget, right? Every startup's under a strict budget. They need to get by. This makes it cheaper for them. And that's it. Welcome to Thread. Now you know about new technology. I hope next time everyone raises their hand. Feel free to go check it out. It's a new technology. If you didn't know about it, don't feel bad. We're only really starting the journey to make this something that's in everybody's home. But I'm really excited about it because it's really the internet. This is the thing we've been waiting for to design into the home in low power. So check it out. Go to Thread Group online. You can get all kinds of information about it. Or come find me. I'm happy to talk about it anytime. Thanks, everyone. Enjoy the rest of Computex.
Thank you, Zach, for joining us this afternoon. And the last but not least speaker of the forum will be Ron Martino, VP and General Manager of IMS Application Processor Business and Advanced Technology Adoption in Microcontroller Group, NXP Semiconductors. He's responsible for driving the broad adoption and rapid growth of the IMX application processor business across consumer, industrial, and automotive applications. So without further ado, ladies and gentlemen, let us welcome Ron.
Well, thank you for having me. It's great to follow such great presenters in terms of customers and partners of NXP. And today I'm going to discuss secure connections for a smarter world. NXP, which is the formation of, or the combination of Freescale and NXP, is focused on achieving and enabling a smart, secure, and connected world. There have been many projections of the total number of connected embedded devices to be in the range of 30 to 40 billion in the 2020 timeframe. Security is an absolute critical element of these devices being successful. Without security, there's huge financial risk, and with the highest levels of security, there's significant economic savings against theft, savings against the avoidance of malicious attacks on devices that are enabled. The smart world crosses many different segments, all segments actually: automotive, retail, home, industrial. And as the chart shows, the foundation or the root of this smart world is around technology innovation. It involves process technologies such as alternative non-volatile memories. It involves innovation in embedded processing, such as application processors, where we innovate for power, integration, and security. Solutions are being developed around embedded processing capability, around connectivity protocols such as you just heard in terms of Thread and Wi-Fi. And as I'm going to focus in this discussion, an increasing need for multi-sensory capability to interface with the machine world around video, image, graphics, and voice. As we look at the seamless HMI requirements of the future, which are critical to enable this world, we can look in a retail environment where you have a seamless exchange of an electronic profile with a digital billboard that then transitions to an assistance, a machine assistance in terms of achieving retail activities, shopping, directions. In an industrial environment, having wearable devices with flexible displays that workers use within an industrial environment to improve work efficiency, to have a safer and more secure environment. And then within the automotive environment, where you have the combination or the increase of multiple displays and the use of data associated with secure driving of the car, combined with increased content that is downloading from over the air. The i.MX application processors that NXP is developing are key to enabling this seamless HMI as we look at future requirements. The next generation i.MX platform, which is i.MX 8, is now available in our labs and will start to roll out. The i.MX 8 family enables sensing capability with enhanced video, enhanced graphics that allows us to augment reality in a seamless and simple way, and not in a complicated virtual reality way, but a seamless and simple way in every day in your life. We've introduced novel security concepts in hardware, such as true hardware virtualization, to enable some of the complexities of dealing with these future systems. In addition, we can convert any object or any surface, it doesn't have to be display. By the use of vision and display capability, any surface can be an interface into a machine in terms of tracking objects, characterizing them, characterizing the human that's interacting, and then projecting information to assist that person throughout your home, throughout a retail space. Greater accessibility can be achieved through the use of more seamless voice recognition, more seamless gesture recognition, as has been demonstrated in some of the prior presenters' demonstrations and examples. And with i.MX application processors, we also have a great level of scalability that enables efficient reuse for very valuable R&D dollars in terms of development efficiency and helping customers get to market faster through the various concepts that go beyond just the reuse of a CPU, but it gets to pin-compatible reuse, subsystem reuse, broad software reuse across a wide range of performance levels that you can quickly scale your system. Teaching machines how to see is becoming a very important aspect of enabling this seamless interaction. The concepts of cameras being more pervasive on all the different devices that we work, the streaming of that data and the use of that data, a vision IoT concept, enabling that in innovative ways so that it's low power, it's cost effective, and efficient processing to enable this. Multiple applications around security and identification, vehicle safety, applications such as video interaction and communication, as well as classification in security systems, are key for vision. Video and the video Internet of Things. The use of video is going to become more pervasive in how we communicate and how we interact. Some companies are predicting that up to 79% of all traffic will be video-based. The habits that individuals use or the use cases that need to be addressed is multiple video content streaming to multiple devices in multiple rooms on demand, combined with the increasing content that's coming from devices around the home, such as cameras. The combination of this increased media content and the increase in connected devices that's been discussed in other forums and in this conference is causing a convergence in the home network in terms of optimization of this data traffic and this interaction. It's requiring interaction of personal devices, interaction with the cloud in terms of communicating to the cloud, getting information from the cloud, interaction between the appliances, interaction between the various sensing nodes that are increasing in number within the home. It's leading to expanded ecosystems and services that require and can benefit significantly from these voice, these gesture, these new HMI capabilities that need to evolve and need to be very effective to proliferate through embedded systems. As we look at this challenge and we look at what's happening with the systems, increased number of displays. Many of these systems are going to have multiple domains that you want to optimize, multiple different use cases. In some cases, you'll have a need for highly secure or highly safe domains that need to be optimized. And at the same time, and in the same device, running on the same embedded processor, you'll have capability that's going to be open, access from connectivity from sources that are less secure. The information is less proven. But you're going to want to have access, very open access to that information in order to effectively operate and seamlessly provide information in and out of the system. Examples of these multiple domain solutions include an automobile, a connected device, where there's critical information and function associated with your cluster or meter within the car that gives you speed, gives you attributes of the car that's critical to its function that the driver must be aware. And then you have more transactions that are taking place over the air, malicious attacks that are coming in to influence the behavior of the vehicle, accessing the network. Those two domains you want to treat and you want to protect and manage separately, and you want to validate that the open side, if it does have access to the secure side, is done in a very intelligent way with the appropriate monitoring. A second example is using children's educational tablets. You have an environment that you want secure. You want to avoid the ability for predator to access and interface with the children. You want to protect the children from accessing information that is less appropriate for them to access. But at the same time, you want a supervisor to have the ability to quickly pull down information from multiple sources from the web, to validate the content, to construct the information necessary and appropriate for the children, and then lock it in the secure world. These concepts will start to become more and more pervasive, whether it's medical devices taking critical information or monitoring patients, whether it's point-of-sale terminals that have access and more connectivity but still require financial security on the transaction side. Robotics, industrial devices, and security systems all face this challenge. One of the challenges that arise is how does one achieve the virtualization? How does one do this without performance impacts, dealing with the many layers of abstraction, management of the interfaces in a way that's efficient and secure, and dealing with the higher level of complexity associated with this in terms of increased code size, test cases, and cost of certification. The i.MX 8 system, which is now in the labs and is rolling out in June to our initial alpha customers, approaches this in a unique way in the industry. We've introduced pure hardware separation that can be defined by our users or our customers. You can create from the interface a simple UART through an entire memory path, through all the memory registers, through the CPU, the GPU, and the display controller, a completely independent hardware domain that does not allow interaction with the other hardware domains. Create a hardware vault. You can configure this, and you can solve a number of challenging problems. By doing this, compared to competitors that use a single GPU and display controller, where you have multiple OSs that have transactions that you need to arbitrate, you need arbitration, you need priorities, you need deterministic outcomes for QoS. With the hardware separation, you can completely eliminate the need for software virtualization on the GPU and the display controller, and you can operate a system with one domain that has its own independent hardware on a chip. Cost-effective, secure, no probability of interaction between the two domains. We've enhanced this by taking our domain controller and allowing for fine-grained control of the peripherals and I/O, where you can create up to 16 different security domains or domains to be applied for different activities that happen in your system. Combining this with the hardware separation, you can deal with things such as firmware downloads, where you can download the firmware on your processor. You can isolate it with a hardware environment. You can run a watchdog to monitor the activity of that code running. You can look for inappropriate or undesired activity. And once you're comfortable that the code is acceptable, you can have it transition into the domain where it can operate on more critical functions of the application processor in the system. So combining the architectural approach that I just described and looking at the security challenge, the security challenge involves many aspects of how we interface with the digital world. NXP brings capability and leadership in the financial transaction world for financial payments, working with banks and governments, working with passport control to protect information with things such as a secure element. Combining that capability with the history that Freescale has brought in terms of embedded hardware security around crypto and tamper protection, and techniques around high assurance boot, we can create a highly secure system that can adapt to the various applications that exceeds the capability of most that are in the industry. What we've recently announced is our i.MX8 first hardware that's in the labs, and we call it the Multi-Sensory Enablement Kit. What we're showing on the bottom is the enhancement on the graphics capability, where we're running a fractal on the highest performance i.MX6 versus the i.MX8 MEK, with over 1 billion operations per frame and over 207 frames for the sequence. We're over 7 to 8 times faster from a graphics shader performance. What we have in this system is enablement of the isolation techniques, a highly rich computational engine that includes the first A72 ARM core for automotive applications, A53 core complex, plus a number of processing complexes and subsystems that can act independent within the system. We use techniques in terms of hardware acceleration for vision detection, for enhanced graphics, tessellation, and geometry shading, so you can achieve high-grained resolution or high details in a very power-efficient way. We've selected IP that is most power-efficient in the industry and techniques with hardware acceleration to achieve these multisensory capabilities in a very efficient way. We can support up to 4 displays and more under certain use cases. We have embedded in this real-time subsystems that enable for sensor hubs. So if you're trying to take in more sensing capability, such as biometric data as part of a in-vehicle monitoring of a driver, the capability is there to pull in multiple sensing capability, audio processing, speech processing, as well as integration with radio and connectivity solutions. The i.MX system, i.MX8, solves many of the challenges to enable the smart, secure, and connected world. It does it through the highest level of scalability around CPU, around graphics engines. It brings in high levels of video capability. The integration of these real-time domains, these connectivity expansion in terms of a wide variety of wireless and wired connectivity capability, as well as the audio processing, helps make these systems more cost-effective to allow them to become pervasive. And then, as I've discussed, by truly enhancing how to achieve safety and security through novel techniques such as this hardware separation and display technology that is set up to always guarantee critical information is displayed, even if the entire Cortex-A or rich OS domain fails and the system has to restart or reboot. We have independent paths for delivering information for highly safe conditions. The focus of I.M8 is enabling this world of secure connected devices. It's doing it in a way where it's looking at all of the devices you interact with in your life, that you interact with every day in terms of your activities, and finding a way to enable them with a scalable application processor family that is cost-effective, power-efficient, and can truly be integrated into the systems that consumers will buy and use pervasively. So with that, that is the last slide, and I thank you for your attention, and enjoy the rest of Computech.
Thank you, Ron, for your excellent presentation. And with that, we conclude the forum on IoT ecosystem partnerships. Once again, ladies and gentlemen, we would like to remind you to please take a few minutes to fill out our online questionnaire. You'll be able to access the online questionnaire by scanning the QR code that's located on the backside of your name badge with your smartphone. May I also remind you that the CPX conference tomorrow will begin at 9 o'clock. Once again, thank you for joining us today, and we hope to see you again tomorrow.